Okay, we are live in the world of lives, all the lives. Okay. Oh wait, I forgot to do something. There. All right, chat should be working. There we go. Now let's get this party started. All right, we're gonna try and actually get this done today. I don't know if we're gonna succeed, but we're gonna try real hard. Dear God, I gotta say that fucking dots is difficult. It's like actually hard.
Okay, so
Okay, let's see. It's a racing one. It's the racing one again. Oh, I want to fix that. I want to fix that so bad right now. GitHub Unity dots. Can I zoom in? No, maybe. Hello, everybody. It is good to see everybody here. So, like 2 people that are
Really the default one.
here we go. I want mine. Here we go. Everybody here. Okay, we're good to go. Oh, sorry to everybody who was looking forward to an early stream. If anybody's really there for that, but I posted out on my Twitter and my Blue Sky that I was going to be late today due to plumbers. We had an issue with the bathroom where we lost all pressure in one of the in the tub, and so we had to call in a plumber, and they were here first thing in the morning. So yeah. Okay, so we are, where are we here? Here. We have a graphical wheel. This has enough information that we can do stuff with it, potentially. What we want to do. Sorry. So we can get the local transform of the wheel itself relative to the suspension. And if we use this as I think this is giving me a read write. So I can probably update this. I think I've got a set in here somewhere. There's that, and then it's this one. Okay, so if I say do graphical wheel, right? And then we do position, and we say we want to bring it down on the Y to the position of the suspension, right? Which I believe we're passing in the wheel. Yeah, we're passing in the wheel data, which I think we should have enough info on the wheel data itself to do everything here. Here we go. Yeah, here we go. So if actually we might not even need this. I might be able to do this entirely like this. So wheel data needs to be read white, read white, read write. So if I do that, and then we're not initiating, no. We'd be grabbing at some point if we wanted to, but we could do this. And then we've got the rigid transform of the world from suspension, world from chassis. Let's take a look at these. So if we do debug.log, and then we do world from, actually no, we don't need to debug for that. We can just do it. Like we can just look at it. All right. So we're using this wheel here. We come down, we should be able to see local to world, local to transform, local transform, local to world. Oh, sorry. There we go. Local to suspension and local to chassis. Okay, so if we say we want to move it down, right? I think all we'd have to do is do the, like, update the position, right? So we can test that by coming into here. And we go like that. And then we want to grab the suspension itself. So we want the front left suspension. We want the front left wheel specifically. And if we adjust this, what happens? Oh my God, it adjusts. And we can adjust it locally, and that's all we care about. Fucking right. So if I grab the local transform, right? So we do read write for local transform dot value read write dot position equals oh wait, we need more data on the wheel itself. What if we pile all the data on the wheel? Could we just pile enough information? But then we'd have to like go about the wheel and everything like that. Do everything on the wheel, and I want to try and avoid that. There. Vehicle suspension authoring. Okay, so we've got these pieces of data, kind of in this order. So there's the wheel, and we need to get the suspension info. So we need to grab the suspension data. And the suspension data can be grabbed through the no, I want the suspension, right? Yeah. Oh, sorry. Not graphical wheel. Suspension. And then we do, right? But I think it's more like if we come over to here, we can get rid of a lot of this. We come over to here, right? Like we're getting the data itself. So world.get rigid body chassis index. Where's chassis index coming from again? Vehicle. Oh, wait, chassis entity. Get rigid body by index. Oh, so if we have the world, do we have the world? We don't have the world. Let's get the world. I think we're going to need the world anyways. Where's world coming from? Oh, here it is. Singleton. Then it would be world.get rigid body. We actually might be able to do this without needing this. Get world.get. Oh no, that's just rigid body. Damn it. Damn it. I don't care about the rigid body. Okay, so we can't use world. What's the issue here? We do need world because if I'm not mistaken, it's required for some of the data to work. So can I use it here? World? Hit joint index. Let's take a look at what this singleton actually has in it. Dots API queries. This is what we care about right here. Cast ray. Oh yeah, we definitely need that. Calculate distance. Calculate colliders. Go API. Interesting. Oh. If I were, I actually kind of wonder what can we take this information and potentially add it as like a suspension data here, like a vehicle suspension data. Like, can I do that? And then how would I get that? If I do build suspension data from suspension game object. No, just the data. That's all I care about. Which is effectively this, right? New suspension data. Wait a second. Wait. Build suspension data from suspension game object. How did they do this? So this is the Baker get entity. But we don't care about that. What if I just use get entity? Get component data. Vehicle. No, that's not correct either. Get entity suspension. Okay, so what we want to do is we have the game object, right? So we do the vehicle suspension data equals my audio is low again. Oh, sorry. Is this better? Sorry, it was pretty far away from my face, so that was probably it. Yeah. Okay, so effectively what we want to do is do this. But we're not going to bother with the entity, the vehicle chassis, but we've already got it, so we could just do that. Where's the vehicle chassis anyways? Learn vehicle chassis. The local transform here would be based off of the game object itself. So if I do suspension, or sorry, authoring dot suspension. Get component. Local transform. Static. This is like literally local transform. Hmm. Sorry, give me a second here. I'm just thinking. So this is local transform. Suspension position. I feel like we have that though. It's really the other data that we need though, right? Yeah, we don't care about position. We care about the rest length and the dampening. Oh wait, no, but the position is part of that, and the wheel doesn't need to be there because this doesn't need to care about the wheel. And this doesn't need to be there. Honestly, this some of this barely needs to be there. This can be for like each one of these could be its own thing. I think this gets easier if I add all of this in here instead. We get rid of suspension. We get rid of no, we keep that. What's the issue here? Cannot convert. Wait, what's going on now? Oh, right, I got rid of the vehicle. Oops. There we go. Would it be better to make new components to keep the struct under 64? It depends. It kind of depends, right? Like, what are you doing? What data is actually required? And what data can be thrown away? And I just have the struct limit stuck in my head from C, C++. There's a struct limit in C and C++? Like for size? Add-on warning me about cache lines. Oh, okay. It's an R8. So it's relative to the CPU because not all CPUs have the same cache limits. They're fairly standard though. Like CPU caching is usually pretty standard. I think size wise across the board almost. It's pretty ubiquitous. I think I've got a little bit more just because I've got so many CPU cores, right? But it's sorry. I don't know. Everything's a bit relative, but like we could we could drop things to make this struct smaller. And yes, it would make it execute faster. Uh Tio Namia, welcome back. You got a Threadripper? I do have a Threadripper. I have a 32 core Threadripper. I have the Pro series. 5975WX 32 core 32 core Threadripper. That's actually really useful. It's actually something that I was thinking about. I was trying to figure out if I could get something to tell me about the size of this. So I could figure out alignment. Yeah, but it so far I haven't looked very deeply into it. I'm sure that there is something, but I haven't found it yet. Because I think these entities are just integers. I'm going to leave them there for now because I don't know if I'm going to need them, and I will remove them if I don't use them. I was debating saving up for one to speed up CPU renders. It does a really good job at that. They do a really good job at that. But goddamn, are they expensive? They are so expensive. I got it for the jobs. I was doing Houdini job stuff, and I got it because I wanted to be able to process lots of jobs. And then I don't use it for that anymore. So rip me. Okay, where's the? Here we go. That would be a way, yeah. I think the consumer, quite possibly. I've not looked at some of the new CPUs. I went the 4090 for faster Blender render times. I thought about getting a 40 series and I couldn't justify it. I'm on a 3090. I built this system I think 2 months before the 40 series started dropping. Or no, just after the 40 series dropped. But like there was CPU problem, there was power issues, and I didn't want to invest in it yet. So I stayed with the 3090. I think I think that's how that went down. Or I got it right before the 40 series because I was just like I kind of need it now. Oh, my previous computer was like pretty old. I think my previous computer before this one was a 1070 Ti, and now I'm on a 3090 Ti. Yeah, I think it was yeah, it was something like that. It was an older system. It wasn't the greatest. I'm trying to think of how I'm gonna get. Is there so? Can I get data from a game object? If I pass in a game object, how do I get data from it? Unity get data from game object script. Oh, you use get component. Once you have the game object, use get component your script to retrieve information. Oh, okay. So here we use, if we do this and we do suspension, uh, vehicle subs authoring, right? This this gets us the data, right? And then we have access to it, right? Suspension data authoring dot dampening. Oh, we do. Sweet. It's fucking perfect. Now I can just I don't need this. And I can put things in the way that I actually want them in. Oh, that makes me happy. We can come down here and we can do this. This is going to be equal to suspension data authoring dot rest length. Oops. Suspension max length. Suspension strength equals suspension dampening. My ZBrush viewport is like 5 FPS with my bigger hard surface scenes with an old as well i7 6 core 12 threads. 5 FPS. That's insane. If you're getting 5 FPS in fucking ZBrush, that's quite the scene. Sure, how to get component worked in dots. The only thing I see is get component data, shrug. Yeah, no, that so to be fair, we're not getting it here, right? We're getting it outside of. So this isn't this part up here is not dots yet. This is still some this is still outside of dots. This after this step we're in dots. So this is actually attaching this is the part where we actually create the entities and attach them to the object, the game objects, right? Yeah, the authoring phase. So now we've got our suspension data. There we go. Now I have now I have all of the information in one spot. Now I should be able to raise and lower the wheels based off of the suspension info here, right? So if I do let's put the wheel to the maximum amount that it's allowed to be, right? So if I do local to world dot position dot value read only dot position, or actually we should say read write, right? Oh wait, no, this is not local to world. This is local transform position equals math dot or float 3 dot max. Actually, I guess because we're only adjusting the. Give me a second. I'm thinking. Okay, so calculate the max. Sorry, give me a second. I'm deep into thoughts here. So we want to take the current position of it, and we want to take the world from chassis. So this would be wheel data dot value read only dot world from chassis dot position POS is our start position, right? So this is where we start. This is our rest, and we want to push it down as far as we possibly can, right? Then we take and we add to it the wheel data dot value read only dot max length, and this would be local transform dot value read only dot up, and that's a multiply. And this equals our new wheel position. All right, 1 second to do. So I just use Blender. I mostly use a combination. I use a combination. Mostly it's Maya and Houdini, but I really want it to be Blender and Houdini. Mainly because I would like to get rid of Maya altogether. I would rather not. Okay, so we grab the wheel now, the local transform, we increase the Y. This works. I guess we're not setting it properly. Sup, Fox? Very cute. To do. Do we need to do a linear velocity? Like, do we need to do this with actual physics? Because it doesn't have a rigid body. And can't beat free for what it does. It is hard to beat free.
Again, like I said, part of the reason why I told you to wait and then download the exact project files is so you get exactly the same package. Hello and welcome. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to start with regular objects. So in this case, let's go ahead. Whereas if entities, so that's a cube, this you absolutely need to be threaded when we implement jobs in a few lectures. So I just want to very quickly point that out. Okay, so here we have our for each. Now, like I said, this will cycle through all the entities, transform. And now inside we have two nice properties. Positions, value R3 onto it. And by the way, float3, this is a special type that is part of the unity.mathematics library. So let's go up here at using unity.mathematics on how it's super fast and specifically designed for dots and bursts. So this float3 over here, brand new dependent. This one for the axis time, and finally delta time. So yep, just like this. Okay.
Oh, it's not working. Local transform, read write. Yeah. We give it its new position. I wonder if it has something that I'm not knowing about. Okay, here's our wheel. We can move the wheel. The wheel can be moved using the local transform. If I hit play, I can move it using the local transform. But for some reason, it doesn't want to work on the update. Why work on update? Yeah, look at that. The local transform's not changing. But if I come into here and I change the local transform, it does work. So something's not changing the local transform. Something's causing the local transform not to update. So let's do a debug.log, and then we'll say the old local transform. And then we do the new local transform. Oh, look, we're not executing it. That would be why. It's probably because this doesn't have all the things that we're asking for. Do we need a world transform? We do not need world transform. Do we need physics velocity? We do not need physics velocity. Nor do we have physics velocity, I think is the other point. Okay, so let's grab a wheel. So we have buffer local to world, local to transform, parent, previous parent, scene select, scene tag, simulate, and vehicle wheel data. Okay, there we go. I think this should work. Okay. It worked. Um, okay. What if we have public and then we say rest position. And then we say that this, but rest position. Wait, what? Local to world matrix. Local position, and I think it's local. Sorry, authoring dot transform dot local rotation. To do dot. We don't do that. We do this, and then it's where is it? We had it around here somewhere. Here we go. Local transform. What if I just do that? Would this work? I don't think this is going to work. What if I just make this a transform? I don't think that you can, because I don't think these transforms are valid. Okay, so we're going to go back to rigid position, right? Rigid position is the correct way to do this. And then we just need to remember how we were, I think it's this probably. No, that's a local transform, not a rigid position. We'll transform. I guess we could just do it as a local transform. Rest position or rest. Yeah, rest position. Do damn it. Where are we? Right here. This is what we want. Authoring dot transform. Okay, so now we have the rest position. Rest position. Position. I think this should work. Well, the wheels are definitely there. Let's see whether or not they have any. We're not adjusting it. It's still 0. It's supposed to be the max, though. We could do a local to world. Ref read only local to world. Wait, am I even seeing any consoles? There we go. We're getting 0 on both. That doesn't make any sense. So apparently, based off of our rest position, plus the up vector, plus multiplied by the max length, we get nothing. Actually, I want this to be minus. So we're getting nothing here for some reason. Nothing. 0. Nada. This math equation returns 0. What if we calculate this twice? There. Let's see if this is like just a weird bug that not necessarily bug, but like just a weird interaction, right? Where things are getting like smushed and overwritten and stuff. No, that math equation actually returns 0. Funny numbers. Yeah, funny numbers. We're getting a 0 back. Okay, so apparently if we take the position, we multiply. Do we not have a max length? Is that the problem? 'Cause that's the only thing I can think of, is that we don't have a max length. Okay, we hit this. Then we come down to the wheel. We scroll down. We are not getting a max length. Okay. That is why. Hey y'all. I think I found the problem. We'll say rest length of 5 and then 10. I think this is way off. This is like super off. we're gonna, we're gonna see. Okay, there we go. Oh my god, it worked. Okay, that worked. we did it. We did it. We fucking got it working, y'all. Okay, let's do the wheels now. Vehicle configuration. Why, what? Oh, yeah. We don't care about this one. This is fine. This is we can now do a for loop for the wheels, right? Because the wheels are a object, a list of objects, right? No, this is an individual wheel. Right. An individual wheel. Max length. Much better. Now I can come up to this, and we can tweak this max length down a lot. And we can say we want the very, very center of the wheel and stuff like that to come into certain plays here. There we go. And then our rest length. We need some way of dictating our rest length, right? I can't remember what this was again. Oh wait, this is the radius, right? There we go. There's our suspension. We have very sane things. I don't know what rest length is right now off the top of my head, but if I'm not mistaken, rest length is like the middle, is going to be the middle. And I don't think I'm using it. For now, I think I'm going to get rid of it. Nah, you know what? I'm going to leave it. We'll come back to it. If we don't use it by the end, we'll just completely get rid of it. Because I actually just want rest location. Okay. So I think I only want rest location. 20% sure. There we go. Okay, so now if we build this, we come back into here and we hit play. We can see that it goes down to there, which is beautiful. It's almost what we wanted. If we bring this up, oh, it doesn't work. Damn it. we need to bring this down maybe a bit more. There we go. I don't know why it's minus 12, but 1.2. Let's do that. Let's take a look at what this one looks like. That seems a little bit more sane. Okay, so we're going to do that one. So what we're going to do is can we just copy all of this? No, we can't copy. We can't just copy all of it, can we? Okay, no. Let me write it down. That's kind of poopy. But whatever, it is what it is. So we're going to say the rest length is 5. It's not right, but whatever. Yeah, that's what I wanted. Max length is 0.12. Strength is 25 for now. And dampening will be 50. This allows us to have each wheel right next to the question mark. The 3 dots. Copy component. Ah. Then I can come up here and paste component. Hell yeah, that was what I was looking for. Now I got to do this for the wheel too. Wait, we're not drawing the wheel radius, are we? Oh no, we are. Yay. This one I'm gonna write down because I've had to do this more than once. Do, do, do. Zero 0.47. 0.4. 0.47. There we go. Look at that. I really like the Draw Gizmos. Draw Gizmos is really good. It's so cool. Love it. 10 out of 10. Okay, so now if I hit play, all the wheels should drop. They all dropped. Look at that. They all dropped. They're all off. It works. It works. It works. Now let's apply an upward force to the chassis now. Okay, so let's see if we can get this to float. Just float by itself. Which is going to be down here where we do the upward force thing. Apply impulse. Physics world dot apply in. Right. Right. It's not world. It's physics world. Because it's physics world singleton. Right? This is not incorrect, right? Oh, this is just a physics world in this sense here. There we go. Okay. Apply index. And this is going to be on the CE index, which is the chassis. So we're going to say get vehicle chassis index. Vehicle. Hey, I was right. This is what that is. There. Local up. Compute what current local up is. Okay. Float, is that supposed to be a... Okay, float is just a is literally just a float. Or sorry, front force is just a force. Force. So this would be a float, and it would be force equals, we'll say 100. And then the point that we want to do it at is does this take a world position point or just a point? The point. in world space. Okay, so that would be the local to world transform. Local to world dot dot value read only dot position. This is going to be hopefully this is going to be very violent. That's what I want. I want this to be super violent. Just the most violent. The most violent possible. It's not applying the force. You will get nothing and like it. This does this have physics on it? Maybe the impulse was not strong enough. Maybe this is what we need. Right here. Just max. We're gonna go for 10,000. We're applying 10,000 whatever units of pressure. And we're not getting anything. God damn it. What the fuck? This is a world position, right? Dot log world position. There's our world position. I believe that's actually the world position though. So if I do suspension, right? We look at the world position. There's our world position. Our world position's oh wait. The world position's a little off because we're not using the suspension world position. Fuck. God damn it. Oh wait. We have to convert to a world position. Right? From the local position. Convert local position to world position. That's not it. Okay. This is it. So this becomes wheel data. Wheel data. Because wheel data, it has a read only of the rest position dot transform point. Oh wait, no. this would be local transform. Yeah, so it would be local transform dot value read only dot transform point, and then this would be wheel data dot value read only dot rest point position. And this returns back a world to local, I think. No, a float 3. Sorry. Float 3. Impulse point equals dot position. Then we do the impulse at that location. Impulse point. Direction forward. Inverse transform point. Transform a direction by the inverse of this transform. From rotation. Okay, whatever. We're gonna try that. And now we hit play. Let's do a debug. Let's see where this impulse is actually being applied. Okay. Debug dot, or sorry, we want to draw the sphere, right? How did we draw spheres again? Draw a sphere at impulse point. That's not helpful. Where's the I think I've got something in here, right? Wired disk. Gizmos. No, I want to use that new one. Where's the bars? Where's what fucking plugin was that? Here it is. 3D. Check sphere. Overlap box. Single sphere. I just want to draw a fucking box. Object mover. No. Debug capsuled cast. I don't actually want it to do the cast. Debug circle. This is more along of what we want. Circle cast. Debug point. Wire sphere. This is what we want. Debug wire sphere. debug wire sphere, which would be, I think this is what, Twitter dot lib dot debug extensions. Draw wires. Might, this doesn't seem right. Wire sphere. Dot debug extensions dot draw wire sphere. There it is. Fuck, that's long. It's so long. Okay, so it takes the point, then the color, right? So this would be the impulse point, a color, color dot red, a radius, but we don't have to provide anything else. Beautiful. Someday over the rainbow. Let's see if we get our impulse point. Look at our impulse point. Our one, it's huge. that's a problem and a half right there. What's the size, the default size on this one? Radius is a 1. Yeah, that's why. Radius of 0.25. There we go. Not so much with C, C++. C, C++ isn't too bad, I don't think. For the most part. I think it's pretty good. At least the Unreal side of it is. I've not done too much with C and C++ outside of Unreal. Okay, so all of them are driving, all of them are at the wrong spot. I can't imagine why. Our world location is wrong because our world location is offset by where the wheel currently is. And we don't want that. So we have to convert our local transform into a world transform. Based off the offset. Position plus. Okay, so what we need to do is transform the rest position to world space. Returns the result of transforming a float 3 point by affine transform. What is an affine transform? Affine. The affine transform class represents a 2D affine that performs a linear mapping from 2D coordinates to other 2D coordinates that preserve the straightness and parallel of the lines. So what? What exactly? How does that convert? What? It's shown above. The fine map is the correspond the composition of two functions. A translation in a linear map, ordinary vector algebra uses matrix multiplication to represent linear maps and vector addition to represent translations. Formally, in the finite dimensional case, if a linear map is represented by one sec. Math to convert a local transform to a world transform. Multiply the object's location transform matrix by the parent world transformation matrix if it has one, essentially applying the local rotation scale. And I had Visual Studio miss stuff was a big reason I like CLion. Haven't had that problem since. Yeah, CLion, JetBrains' IntelliJ is really good. Okay, so what if, just hear me out here. What if I take the world transform, oh, wait, I know. Get the difference between the current local transform. Wait a second. I remember why I wanted this. Get the chassis, or sorry, get the wait, we've got one sec. We've got some information here that actually tells us something potentially that we could use. I think we can use this. Because I think this gives us the rigid body from yeah, so we've got the rigid transform, so we can use that. So if we convert this, because this is a standard point, convert rigid body, rigid transform form for convert world from location there. What if we do that? Wait. This is probably it. Not this. We want wheel data dot world was it? It was world from suspension. Returns the rigid transform constructed by the first performing a rotation. I don't care about the rotation right now. Give me 1 second. I'll be right back. Sorry about that. My girlfriend got home from the jury duty selection thing that she had to do. And we had the plumber come in today. And that's why it was late for anybody who showed up later than, as soon as I started streaming pretty much. So I had to quickly just go over with her the findings. And they fixed our problem. It was super cheap and it was nice. So, but yeah. So my impulses are not being applied to the rigid body. God damn it. Apply all fucking things. Oof. Okay. Can I get uh suspension index? It's not a rigid body though. Get parent entity index. Get parent entity. Is this an index? I feel like this entity is an index. The ID of an entity. I was right. Okay, so if that's an index, we'll get suspension data from suspension to entity. Blech. Which gives us our point that we want to do the up force on. There we go. Look at that. We figured it out. We can't put this in a job. Vehicle suspension data. What we want is world local to world is actually what we want. We don't really care about the rest of it. Suspension world position. Suspension local to world. Oh my god, it's working. Would this maybe be a negative force? And what if our force is like super powerful? Like really ungodly powerful. Can I do this, by the way? No. Can I do this? No. Can I do this? Yes. Beautiful. Figuring out how to write those numbers is kind of important. All right, so we're not actually applying the force. I don't think the force is actually being applied to the physics object that is the rigid body. So we have the rigid body entity, and it's not applying a force. So if we do dots, apply force to a rigid body.
Hello, everybody, and welcome to.
You didn't know that you could do the underscores? Oh yeah, it allows you to better visualize the number. It's available in other languages. That's how I knew about it. I do it in, it's something that's available in Python. Formatting. Numbers underscore. Yeah. I've used it a handful of
To
times.
today's video, we're going to be showing you how to do the equivalent of a rigid body.add force inside Unity's new physics system for the entity component system. If you're familiar with the add force method in Unity, then you know that it gives us a way to add physical forces to objects within our game in order for them to move around and interact with each other. And this is an extremely handy method to have. Now, if you tried to use this in Unity's entity component system, it's really easy to miss because it's actually set up as an extension method called apply impulse. Now, this apply impulse method basically allows us to apply linear or angular forces on our object. Now,
You know, not necessarily the worst way to do things.
today we're going to keep things simple and just apply linear forces to our objects. And by the way, if you're still new to Unity's ECS and some of the stuff just isn't making that much sense to you, I will leave some links to some other videos that I've made up in the card as well as the descriptions below. It's going to help you get up to speed on some of the terminology as well as how to set up a project in Unity ECS and kind of going over the basics of what entities, components, and systems are. Anyways, before we get into it, I'd just like to say if you do find today's video helpful, I'd really appreciate it if you hit that like button. Also, feel free to subscribe to the channel for lots more videos about Unity's entity component system
I wonder if this guy's American.
and their data-oriented technology stack. Of course, if you have any questions for me or suggestions for any future videos, feel free to leave those down in the comment section below. And before we talk about adding forces to an object, we need to talk about the difference between an impulse and a force within Unity. So if you're familiar with adding forces to rigid bodies traditionally within Unity, you know there are 4 force modes that we can apply forces to our objects in different ways. Now, these force modes are broken up into 2 categories where you have instantaneous forces versus continuous forces. And within each of those categories, you have a force mode that factors in mass into the calculation and one that does not factor in mass into the final force calculation. Now, just to keep things on the simpler side, we're just going to be looking at force and impulse today. And even though these are 2 different force modes, they're really the same thing. The only difference is that an impulse is all the force is applied instantaneously, whereas with a force, that force is applied over 1 second of time. Now, to demonstrate this, I've set up this little scene in Unity where we have 2 spheres that are implementing 2 different force modes. So the green one is implementing the force mode, whereas the blue one is implementing the impulse force mode. Now, these are still just regular Unity mono behaviors right now, but you see if we go into the force sphere, I've set the force mode to force and has a force amount of 10. Now, over on the impulse sphere, I've set the force mode to impulse and the force amount to 0.166 repeating. And basically the way we get that is if we just do 10 divided by 60. And I'm doing divided by 60 because I currently have my fixed
Wait. 1 sec. Actually,
time steps set to 60 steps per second. Now, normally in Unity, the default is 50 steps per second, but I've changed it to 60 steps per second, which we'll be talking about when we get to the ECS portion of the video. Now, here's the code that I have set up for this particular example. Just inside our fixed update function here, as long as we're holding down the input key, we're going to apply a force to the rigid body using rigid-body.add force. And this force vector is basically going to control the strength and direction that we're going to be adding force. And then finally, this force mode is, depending on our force mode, if we want an impulse or a force or an acceleration or velocity change. Now, if we enter play mode here and I hold down the space key to begin applying a force to these spheres, you see they move at the exact same speed. And you'll see that if I pause it and move frame by frame, you'll see that these spheres move at the exact same speed. So again, when we set the force mode to force, we're basically spreading that force out over the 1 second period, whereas when we do impulse, we're applying an impulsive force to the sphere every single frame. Now, don't worry if you don't quite understand this. I'm going to have a link to a website down in the description where it basically just explains this in much better detail than I did right now. Now then, moving on to the ECS portion of this video, basically I just have this plane here. It's a simple plane that I made with ProBuilder, and I've attached the convert to entity script on here with the conversion mode of convert and destroy. Now, one thing that you do need to keep in mind if you are going to be recreating this yourself and you're using something like ProBuilder to generate your mesh, make sure you turn off subdivisions. By default, it sets it to like 3x3 subdivisions, and a problem with that in the current Unity physics implementation is actually when the sphere rolls over one of these subdivisions, it causes it to bump, and that's kind of an unfortunate behavior of the current deterministic physics engine, and I can leave some links down in the description for a little bit more documentation about why that happens if you're curious. So again, just make sure that you generate your mesh without any subdivisions and you won't run into that issue. And then over on the sphere entity, basically I have it set up the exact same way as the other spheres with a sphere collider and a rigid body, but this time we just have the convert to entity script as well as the move force data authoring script. Of course, that move force data authoring script is a custom script that I've created. So it's a public struct called move force data that implements the iComponent data interface. We also have the generate authoring component tag above it, and that allows us to drag this component onto game objects inside of Unity, and then at runtime this will be converted into an ECS data component. All this has on it is a public float for the force amount as well as a public key code for the forward input key, which is the key that we'll press to apply a force to our object. Okay, so here we have our add force system, and this is where I'm going to be creating the system that allows us to add forces to our ECS entities. So at the top here, we're going to make sure to include the following libraries. So we'll of course need unity.entities, unity.mathematics, unity.physics, unity.physics.extensions, which is actually where the extension method lives, that we're going to be using to apply the impulse force over time to our objects. And finally, we just need the Unity engine library. So of course, we have a public class called add force system, which inherits from system base. And when we do that, we just need to make sure to implement the onUpdate method. In here, I've just kind of created the basic container of an entities.forEach function. So we're going to refer to our entity as sphere, and then now we're going to need a reference to a few data components. So you'll see that we have a reference to physics velocity, just called physics velocity, a reference to physics mass called physics mass, and then finally we do an in for read only on the move force data called move force data. Now the first thing we're going to do is check for input, and inside here we can calculate our force vector. So we're going to be casting this to a float 3 because that's what we're going to be using in ECS as opposed to a vector 3. But we're going to calculate this by doing a vector 3.forward, which basically just gives us the forward direction, multiplying that by our move force data dot force amount, so basically how strong we want this to be. And the final thing we need to do is multiply this by delta time. And again, we're doing that so we can apply this force over time rather than just all the force at once. Now, in order to get delta time, we actually have to go outside of this entities.forEach, and we can just do a var delta time equals time dot delta time. And then we can just come back here and multiply by that delta time variable. Now, one thing to point out is this onUpdate function is currently running once every frame. And because we're going to be moving forces and doing physical interactions and things like that, we want this to run on a fixed time step in order to get predictable results out of our game. So in order to get this to run on a fixed time step, we have to add an attribute to our class here. So we're going to be adding in the update in group type of, we're going to be looking for the fixed step simulation system group. Now, this means that the onUpdate function is going to run on a fixed
okay, that's important. This does not need to be. I would like this to be burst compiled, but update in. Wait. This is the I system. Yeah, it's on this one. We do update in group. Type of fixed step simulation group. There we go.
fixed time step as opposed to a variable time step based on the frame rate of our game. Now, by default in Unity ECS, this is set to 60 steps per second, which is why I set the regular time step in Unity to a time step of 60 steps per second. Unfortunately, when you change the fixed time step in the project settings in Unity, it does not affect the fixed time step time in the ECS world. As of right now, the documentation says that right now, in order to change the fixed time step, you actually have to set the time step every single frame. Anyways, back to applying forces. All we need to do is just go to our physics velocity component, and we're going to do a dot apply linear impulse. So again, this is going to just apply an impulse in the linear direction, and we just need to pass in our physics mass component as well as our force vector. Now again, just keep in mind, because this is an extension method, you do need to make sure that you do include the physics.extensions library here. Otherwise, you won't see this apply linear impulse function. And that's
Okay, so first things first. That. And then we come back to our code and we need to get the component of the chassis. We want, what was it? It was, give me a second. Get, okay, so this would be system API dot get component. Physics velocity of the chassis, and this would be physics velocity. And then this would return back the physics velocity equals apply linear impulse. Applies a world space angular impulse. Body position. Ah, here we go. Linear impulse. And we can, okay. Yeah. Okay. So we want this and we can give it the, what? Oh, we need a map. If we give it a mass of, let's say, 8,500, then we give it a force vector. Ah, okay. So, oh yeah, that's the force vector. So what's the problem? So this is the velocity data, then the mass, then the scale is a float. Okay, so it's physics mass. Oh, sakes. Physics mass. So we take that, then we've got the to do. And we need our delta time. And this returns a float, right? Yeah. And then our force, where's our force being applied? Our force is a body, no, body scale is 1, right? Give me a second here. Body scale. Okay, 1 sec. Let's jump to this. So it's okay. So velocity data in out. There's our velocity data. Oh, so this is static. We don't have to. Ah. This is different. This changed. Body scale and impulse. Okay, so this changed. So this would be world, physics world. Right? Yeah, and then we do the chassis physics mass, physics velocity. What the fuck? God damn it. Why do I feel like this is trolling me? These are static, right? Yeah, these are static, so they don't require anything. But what's the parent? Physics world extensions. Okay, so this would be what? Physics world extensions? Extensions. Then we're gonna do this. Times delta time. And this would be the up, yeah, the up. This would be our force vector. There. Okay, and then this takes in, okay, we go like this. The world, the rigid body index, and then the linear impulse. But not the location. Calculate to target. World.apply impulse. Okay, so it is that. Like that is supposed to be correct. So this should be world dot physics world. Let me just double check what their world is. make sure. Your world is a physics world. Okay. So theirs is. What did we name ours? Oh, this is why. That is totally why we were having problems. Physics not apply. Then we give it the desired. No, we give it the index, which is the chassis entity index. Then we give it the impulse direction, which is the force vector. Then we give it the position, which is there. And then we see that we want physics world here. Oops. And wait, let me take another look at this. Rigid body index. No. Oh, yeah. We don't want apply linear. We want apply impulse. But this chassis is the index. Okay, this should theoretically work, maybe? There's like a 2% possibility of this working. Where's my error? Please fly. Please fly. No, not flying. A component with Unity physics velocity has not been added to the entity. We're getting rid of that. What does this take exactly? Rigid body index. Yeah, so that is the rigid body index. So why is this not working? We are literally copying exactly what these people did, and theirs works and ours does not. That flickering has to do with the amount of time it's taking. Hmm. It's because they're not burst compatible. That like the draw is not burst compatible. But we're not getting the appropriate system here. So it doesn't even matter if we have this or not. It's not going to work. Because the force is never being applied. At least it feels like the force is never being applied because I don't think we have. If I go to here, right? Oh, wait, I know why. This chassis is wrong. So we're getting this chassis. This chassis doesn't have the physics body. This has the physics body. The truck cone. So this is what? This is the FLT. Huh? What the? Wait. Oh, there it is. Or a rigid body. What we want to do is we want to take the entity dot parent dot parent dot parent. So instead of doing this, what we want is authoring. We want the entity dot parent. We want the wheels parent, 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 right? But we can do the authoring dot suspension, right? And then the suspension here we know that it has a suspension body and then it goes up to the dots, right? So if I do that, if I do this suspension, and then I can do parent. Maybe? No. Interesting. Get the rigid. Get the entities, parents, parent. Get the, yeah, no, get the, get the suspensions, parent. Parents, parent. So I feel, I mean, I didn't say add component. God damn it. Sorry, get the chassis, parent. This would be authoring dot chassis, vehicle chassis dot get parent. Get component in parent. No, I just want get parent. I just want the parent. Get parent. Chassis dot parent. Fuck. Come on. Get the chassis entity, chassis parent entity. These rigid body index. If you have a collider in non-dots, you can do attach rigid body to get the rigid body. If I have a collider, that would work. Maybe. I want to get the game object that's parented to, like I want to get the parent of a game object, right? So this isn't dots related, right? So I have a game object, right? Game object. And I want to get the parent of this game object. What all has rigid body? The vehicle, the most parent vehicle. So the Truckcoon dots. Okay, one sec. Let this load. Okay. So we look at this here. This has the rigid body, the most parent one. I have the chassis object. I want to get the chassis object's parent, which is this. And that's it. That's all I want. I want to get, how would I, in Unity, how do I get this object's parent? The game object. See the collider on the chassis? Yeah. The box collider? So I've got the authoring dot vehicle chassis, right? This is a game object, and then I can do dot attached. Oh no, I have to get component, right? Which is the box collider. And then this is a box collider. And then from the box collider, this is a really roundabout way to get a parent for some. This is absolutely stupid. Attached rigid body. And then how do I get the object though? The RB is part of the object. Yes, but I want to get the object. I want the object. Dot game object? Dot game object. Oh my god, that is so weird. I hate it and I know it. There we go. Fuck's sake. This is so bad. It's just so bad. That's kind of terrible. Okay, so now when we get the chassis index, right? This is actually referencing this. So if I go runtime, we click on the wheel, we come down here and the chassis references this now. And this has a rigid body attached to it. So if we get the rigid body from it. So that's the vehicle rigid body. Okay, so we've got chassis index. Then we need to get the so we get the physics world, get rigid body, we give it the rigid body value, entity value, right? Because it's an entity. This gives us back the chassis index. Then we pass in the rigid body index, and it does not appear to apply the impulse. Well, we are theoretically getting it. Debug bug dot log chassis index rigid body index. Let's see what it does. Maybe it doesn't give it to us properly. Well, that would be why. It's giving us back 0, and that's incorrect. We can. The index is right here. Or you mean the index of the entity? We can see the entity index down here. We might be able to see the index of... No, we can't. Use debug mode on the inspector 3 dots. Top right. Yeah, but they have it, right? Like just because it doesn't display it doesn't mean that it doesn't have one. Because every entity that gets attached has an index, right? So every one of these has an index or should have an index, right? Well, in theory, right? If not that, then which one has the... You know what he's just thinking about? It has a rigid body on it. Or am I missing? This has the physics collider, the physics velocity, and the physics mass. But I was just thinking about this. Where's the local transform? You can't edit this one. Ooh, sorry. Having the rigid body gives you the physics collider stuff. It gives you all the physics stuff, right? So like we only have these because this has a rigid body. So if I go to this chassis here, this doesn't have it, and here you'll see that this doesn't have any of the physics stuff attached to it. But this does because it has the rigid body. The other thing that we could do is we could get all of the stuff that this guy's using and see if this
setup
works,
to work out.
which is the physics velocity, the physics mass, and then we can try and do the apply linear whatever to it, right? So if we do this, and probably let's try that. This would be a physics velocity, and then chassis velocity. And this would be system API dot get component. Physics velocity. Then we want the physics mass. Physics mass. Then if we come down here and we do this and we do chassis velocity dot apply linear impulse, and then it's the physics mass, chassis mass, and then the force vector, like that. And then we see that we've got an error here. Ref this parameter must be a value type of generic type constraint. We could try this. Then what's the error here? Wait. I don't think that's required. Does this need to be in? Yeah, no, maybe. Oh, QT, thanks for the raid. How have you been? How was your stream? Oh, you know what? Let's just do this. We'll get rid of the position, and then this should just work. This quite possibly might maybe work if we're lucky. If all things go well, hopefully this will just make this thing go flying like crazy fly. Stream went well, I think. Made some progress on the equipment stuff. Nice. Please fly. It did not fly. That is so disappointing. Are we even using the rigid body? I don't think the body's being used at all right now. All right, so if we do 1.f, we do 1.0.f, and then here we give it the location. I think that's what it is. I think this is correct. Body scale, impulse. Body body position. Why is this so weird? Is the velocity data the direction and force? The velocity data is the force vector, which is the up times the force. When we come to this, right, we look at it and it is the linear impulse in world space. I'm a little confused on that one. Yeah, this is a float 3, so this could be the direction. Right? So impulse. And then mass data is some kind of, I think it's just like the physics mass information that's going to be required. The thing that annoys me is that, like, it doesn't work. Make a float. We are, aren't we? I guess this is local up. And we're using down because silly me. That might be why it wasn't working. That's still not working. Do float 3 dot up. I think it's dot up. Okay, so float 3. Do local transform dot up. This just returns a math.up. Math.up is just an up vector, like literally a hard-coded up vector. So if I just do that, math.up, yeah, there we go. But this is still not going to work. The force is intense too. Like, look, it's 1,000,000. Let's see, hundreds, thousands. Yeah, thousands, millions. It's 100 million. Sorry, it's 100,000. No, wait. This is 1,000. This is 100,000. This is 1,000,000. This is 100 million. It's 100 million. The force is 100 million. And we still get nothing. We could try some. I'm gonna see. We could try something. There's something worth trying here. Does this move anything? No, I don't want to move that. I feel like physics don't work in Unity dots. I have another way that I can do this. We could try that. Ow. Okay, so what if we do entity? Does the entity need to be there? I don't think it does. Okay. So what if we do physics velocity, and this is a ref read write, and we say physics velocity. Then we say the mass, and we'd come down here, and this would need to be ref RW, and this would be physics velocity. Then we'd need a ref RW physics mass. We don't need this wheel data. bear with me here. We only have one object in this world that has physics mass on it. So like we could do this. What if we just apply the physics velocity dot value read write then it's physics mass. No, that's not what I said. Oh, it's chassis mass. Okay, whatever. Dot value read only or read write just in case. What if we do this? Will this work? What's the worst that it can happen? It doesn't work? Who cares? It's not working as it is. Let's see if modifying it directly works. I found the problem. There we go. There we go. Oh. It just yeeted the fucking craziness out of that. Yeah, it yeeted it to the moon and back. This is also going to be incredibly insane. Here we go. This is going to be the shit right here. I think this is also going to yeet it, but we're about to find out. No, it did not yeet it. Okay. So 100 is not quite enough. What about 1,000? Uh, 8,500. Actually, I don't know. I don't know if it's set right now. Uh-oh. Here we go. No, yeah, 8,500. Would this be what I need to do the downward force then? What if I just do 8,500? Let's do that. Let's do 8,500. This should at least hopefully, because we're pushing back on it with the same mass, right? So maybe that's the trick. Oh my god, it worked. Somewhat. Where the fuck did it go? Right, we don't. Okay, so that worked. It was a bit much, but it worked. There we go. Now we've added delta time. We should hopefully this should hopefully work now. Play. It's not quite enough to overcome this. So what about 10,000? The nice, sweet little 10,000. Not 10,000. 100,000 is too much. What if it's 85? Like, what if it's that? Do, 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 do. We're pretty close. We're pretty close. We're hovering. We're hovering. Figure out how much force is required to push the vehicle up. I guess this would be like the downward velocity, right? No, because if I do that, then it would never fall. What we need to do is figure out the baseline downward velocity based off of the mass. Figure out how much up force is required to hover the vehicle based on the current mass and gravity. And the current mass. And calculate the power to keep in unity. Calculate force required to hover rigid body. Proportional height. Vector applied hover force. Taken from Unity's tutorial. That will basically try to maintain hover height. Proportional height. Hover height. So now we need to get the chassis position. Get get suspension data. It's not in wheel data. I think here we need to actually go and do the whole. Oh right, this is where we were running into the problem here. Is because we don't have this information. Where did my... Oh, there. I'll be right back. Do do. Hmm. So, yeah. We're not using this. We kind of have two options. Oh, I already have one. We're gonna need the the vehicle configuration, sorry. Yeah, so effectively we're gonna need this anyways. Back to trying to figure out how to do this. Now, I have a couple options that will work. Not resolve. So effectively these need to happen. Yeah. These are a problem. So, since we're dealing with a vehicle that only has 4 wheels, I'm going to do this, and we're going to see if this works. Vehicle suspension 0. 1, 2, 3. Mm-hmm. Okay, so there we go. What we're going to do wheel front right. There we go. But I don't want these to be vehicle. Because it doesn't make sense for them to be vehicle. It's implied. There we go. Why does this not want to work? Oh, it's mine. I figured it out. Hmm? Yeah. Let's fix that. Can I just do this to override it? In the inspector? Oh, apply all. Sweet. Okay, scenes. Play. Look, it's beautiful. Mhm. Unreal. I'm going from Unreal to Unity. A very standard, normal thing that people do all the time, right? 6 months into development. Actually, it's probably longer than that, but like, it's not full time development, so. You go to tools that will help with the project. Yeah, pretty much. So now I have access to all my suspension information, but I don't think I can update the wheels because I don't know if this will allow me to get the. I see. Well, given that you mentioned it wasn't a year yet, I'd say you're still in time to switch engines. Yeah. So what happened essentially is, and Chrono gets to hear this for like the 100th billionth time because he's been here since the start of the Switch. So essentially, what happened was I started getting more and deeper into the mass entity system in Unreal, and the mass entity system in Unreal is effectively equivalent to Unity's dots, and the mass entity system in Unreal is experimental, and nobody uses it. It's been used in like one big name application, and almost nobody has touched it since. And that was the Matrix demo. So I was trying to integrate that in. I need that for the project, but because it's experimental, it's buggy as shit, and it just fails randomly. And I got really tired of it, and I found out like if you use their vehicle system, their vehicle AI system that they provide with, then you can't have like it won't execute things in parallel, and it causes problems, and it crashes your engine and stuff like that. It's just like I could spend a bunch of time debugging and fixing this and rewriting their code effectively, and effectively build the system from the ground up. But it's not really worth it because like at the end of the day, it could be like next year they could overhaul the entity system, and then it would be useless because theirs would very likely be way better than whatever I come up with, right? So I'm just like, if they're not at a point where it's stable, I'm just gonna switch engines potentially. Yeah, I found on the roadmap there is a vehicle controller dots component coming, but in Unity time it will be 9 years. Yeah, so to be fair, in that specific case, I don't care. I was debating whether to make like not use their vehicle system at all for the non-dots version, because they're like the tuning for it was overly complicated, and it didn't offer all that much. You know, it might have been 9 months. I think I started around May last year on this project, but like there was breaks, and like I had a full-time job, like a busy full-time job. So okay, so now if I want to get wheel data for front left wheel, okay, and then get suspension data. Never used dots exactly. I'm going to take a look real quick to see what it is and be right back. Yeah, no worries. Wheel front left data. Suspension front left data. Proportional height is the hover height. Hover height. The hover height, which is the hover height, can be found pretty easily. Hover height is height is suspension point plus rest length. No, just the suspension point versus the wheel position. Actually, what we should do before we even do this, right, is we should see if we can move the wheel, because that's going to be something that needs to be done. Because I don't think the wheel's moving anymore. If I hit play, yeah, the wheel's not moving down. I don't think. We're gonna make sure. Yeah, the wheel doesn't move down. So let's see if we can move the wheel. No, I don't want them to have actual physics. Where did I put the wheel data? Oh, here's the wheel data right here. This is wheel front left data dot I guess we need the system API, right? Yeah, we need to get the vehicle wheel. Okay, so this would be system API. System API dot get component local transform on the wheel. Wheel front left. And this returns back the local transform. And this is wheel front left transform. Local transform. Local transform. Then we can do this. Wheel front left local transform dot position equals wheel data, which is wheel front left wheel data dot rest position. And then local up was calculated this way. So we can do that. And then wheel data, wheel front left dot wheel data dot max length. There. Let's see if this actually updates the wheel position. Oh, wheels. This does not update the wheel position. It doesn't look like it did. Okay, so in this situation, it's system API dot set component, and this would be the vehicle configuration dot value read only dot wheel and then this, which would be that. Then we build. Did it adjust? It did not adjust. Damn it. Fuck. Okay, so I think we need another system just to deal with the wheels. God damn it. Overly complicated. So we could do this for each. Yeah, that's dots for you. So nice. Thank you, dots. Okay, so I think we needed these two. And then we also needed the wheel data. Wheel. Oops. Vehicle wheel data. I'm fairly certain that's all we needed. In system API dot query. And then we take this, plop that in there. There we go. And now we should be able to update the wheel itself here. And now it'd be vehicle. We're just going to, instead of this being vehicle wheel, we'll just say wheel data. So we can type less. Wheel data dot read only. We don't need to get component. It's wheel data dot no, it's local transform dot read write there. This would be wheel data dot value read only. Then we don't need to set it. And I think this should give us what we're looking for. This should adjust all the wheels down. There we go. All the wheels are adjusted down. So yeah, we just needed an extra system. But I think we're also at a point where we can accessing entities in the for each. Mm. Mhm. That should be right, right? Hmm. This is what I just did. Okay. Rotation speed. In system query. We do not add the entity, and then here we just do that. And the entity is just the entity in the last spot here. So what's the issue here? These. So really doesn't like that. We could do this as the wheel job, right? Because now we're not we I think the wheel doesn't need to necessarily update everything. So if I move this into the wheel job here, right? We get rid of that, 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 that. Then we get rid of this. And then we just do everything in this. And here we're going to say that we want to execute to physics world. We're not worried too much about the physics world, so we can get rid of that. Actually, I think we need that for the raycast, and that's going to be somewhat important, maybe. Whatever. Okay, so this is enough information to actually do the. We don't need the physics velocity. We do need the local transform, and we need the world. We need the and then the entity here. I kind of want to see what this entity does. I don't know if I need the entity, but no, I don't think I need it. There we go. And that is a physics world, yeah. And that's an issue because they want us to, I put in that there. Now we execute those on in a job. Do we still drop? We do not drop anymore. Did the wheel debug pop up? The wheel debug. Oh, yeah, it's probably this. I'm going to go back. Just give me a second here. We're going to just delete that. And then we don't need the... Should be able to do that. What the fuck is going on now? What did I get? Oh, wait. Ah, look at that. It's beautiful. So if you use get component, mm, arrogant. Mm. Just complaining that it won't be able to be burst compiled. I like that they have that error. I don't care about it right now, but I like that they have it. Okay, so you cannot can't use a entity. You can't indirectly affect another entity in dots. Okay, let's see if it hovers again. Oh, you know what? I figured it out. I kind of hate it. I figured it out and I know how to fix the problem. I just don't like it. Vehicle wheel system. We can only have one of these per thing. Yeah, I think so. Okay, that's weird. What game are you doing that made you want to use data instead? I can show you the game in Unreal. I'll show you the Unreal game and it will explain it. So this is the game in Unreal. So this is the Unreal game. Unreal version. And Dots allows me to. So Dots is an ECS system, an entity containment system, which allows you to have a lot of AIs on the map at any given time. And because of that, I can make this game work the way that I want it. So we can have lots and lots and lots and lots of AIs. And the AI needs to extend out from just people walking to so people walking and whatnot to vehicles as well. Object references not set to an instance of an object. This exception was thrown from a function compiled with Burst, which has limited exception support. Character variable. What? First person. That's not being used. I have a solution to fix that problem. And all we're going to do is we're just going to delete this. We're not using it anywhere, but its system is getting hooked somehow. And because of that, we're running into that error. Yeah, it was the sample. The sample was causing errors. Allegedly. Okay, so it wasn't that, but it was those wheels. There we go. Yay! So I think there's an issue with vehicle configuration is missing data somehow. No, those are being there. So what's the issue here? Because these two lines are what was causing the problem. Why do read only? Can I do that? No. Okay. Now when I hit play, it's going to error, right? Yeah, okay. But which one is it? $66. This one. So it's the suspension data? No, it's not the suspension data. Is it the wheel data? Oops, I forgot to re-enable the suspension data. It's the wheel data. So it's this one here that's causing the problem. So what's the overall issue here? Why is this causing a problem? These should be set. Oh, that's why. I sees it. I sees it now. No, it was affecting everything. So none of the stuff was running correctly because of it. But specifically, actually, it might have only been affecting the vehicle because it was happening inside of the vehicle's code, so it was crashing out. And it was because this was a null reference. Hmm. 1 second. We're gonna see if we can get the local transform. Okay. We're gonna see if it works. The goal here is to see it move up. What's up, Jack? Or sorry, see the wheel move down and see if it will update in here. I mostly just want to see whether or not if it was related to an error that I wasn't seeing or something like that. So we're going to see whether or not that's the problem. Because that could have been the problem. No, it was not. Okay. Yeah, we can't actually update that, but we might be able to do it using a system API set. So like if we do a system API dot set component, And then we give it the vehicle configuration dot variable redo. We say wheel front left, and then we give it the wheel location transform. This might allow us to update, and if this allows us to update, then we don't have to have a second thing, and I really would rather them not, because I want them to be very tightly coupled. And the reason I want them tightly coupled is because I don't want one to happen and the other one not to happen in the same logical loop. There we go. That worked. Okay, sweet. Fuck yeah. Unity dots get entity data from entity ID.
Frequently in games, one object will need to look at data on another object to determine how that first object should act or react. This is to say that data of one object is dependent on data from another object. So today I'm going to be showing you how to set up one of these types of relationships in Unity's entity component system using the getComponentData method. First, I'll be talking about how this method works and a little bit of the things that you need to watch out for. Then I'll be showing you how to actually use it in practice by setting up the sample scene that you see playing behind me, where we basically have one entity that can follow any random arbitrary entity of our choice. And as always, all the code and project files featured in today's video will be available in the links in the description right below those like and subscribe buttons. And by the way, if you do have any questions or suggestions for future videos, feel free to leave those down in the comment section below, or join us over on Discord over at tmg.dev/discord. All right, so let's talk getComponentData So this is what the method looks like. Again, it's called getComponentData and you'll see that we can define a generic type on here. Now this type must implement the iComponentData interface. So this means like any standard data components inside ECS we can pass inside here. This means though that we cannot pass in any shared components or any managed components. It must be a struct implementing the iComponentData interface. It returns a type of component data from entity. Now this component data from entity type is essentially a collection, basically like a dictionary or a key value pair. So in this case, the key is the entity and the value is the component. And it's literally just going to return a collection of every single entity that has that component on it. So later on in the tutorial video, we're going to create one of these collections based off of the translation component, and it's going to return every single entity in the game world that has a translation component on it. So this means not only all the potential leader entities, but it's also going to return the follower entity as well as the stage. So it's literally just everything that has that type of component on it. And then once we have that collection, we can use the actual entity that we want as the key to key off of in this collection to return the proper value. So say we want to find the translation component of one particular entity in our game world, then we can basically just pass in that entity into that collection, and then that's going to return us the specific translation component that is associated with that entity. You'll see that there is one parameter that we can pass into this function, which is the isReadOnly function. Now this is false by default. However, in general, we pretty much always want to pass in true. So it is possible for us to open up this collection to write access, but it's much more preferred to write to components in other ways than by using this, mainly because if you're not careful about managing when your data is open and closed for write access, you could end up in a race condition. So this is something that you can use. It's there if you need to use it, but it's much preferred that you should write to components in other ways than by using the getComponentData Now, a couple things to note about the getComponentData before we move on to the tutorial section of the video is this is best used inside jobs and inside our entities.forEach functions. Anything outside of that, it's preferred to use the entity manager to actually get the data components from entities, just so we don't have to worry about the extra overhead of creating this component data from entity object. Now, one thing to note is any structural changes are going to invalidate all your references to your component data from entities. So if you do have a reference kind of stored to one of those in your systems and you do end up making some structural changes, that reference will be invalidated. You have to actually go ahead and get that collection again. So you'll see in the tutorial section of the video, I'm actually just getting this collection over and over again every single update, because that's kind of in general the easiest way to do that. And actually getting this collection of entities, it doesn't have a whole lot of performance overhead because remember, we're keying off of a certain component type, so we can basically just go to any chunks that have that certain component type in them, and we're just loading everything right in. So it's not really too difficult because most of the things are grouped together in chunks. However, the thing that we do need to watch out for is when we actually go to access component data from this collection based off of any arbitrary entity as the key. Now, the reason for this is because this is potentially a random memory access, because whatever arbitrary entity that we pass in, that's not necessarily guaranteed to be inside the cache, because we can literally just queue off of any single entity in our game, not necessarily just one that's inside the cache, kind of nearby the entity that we're currently iterating on. Because remember, when we generate this collection, it's literally a collection with every single entity that has that type. Now, if you do want a little bit more information on getComponentData as well as other types of entity data relationships inside Unity ECS, I would highly recommend watching the Unite 2019 talk called Options for Entity Interactions. There's a lot more good information on there. Some of the examples are a little bit outdated with the new code, but I think all the theory principles remain as really good information. So anyways, with all that being said, I think it's time to jump into the tutorial section of this video. All right, so here we are in Unity. I'm just going to give you a quick overview of the project setup so you can see what's going on here. So basically, this white capsule right here, this is going to be essentially the follower entity. So this is going to be following one of the selected entities depending on the key that we press. Now it just has this little yellow sphere above it so we can easily tell which one it is. And the other colored capsules, these are the ones that are basically we're going to be following depending on which key we press. Now this isn't really relevant for the topic of this video, but to just give you a little idea of how this is set up, you see that I have this game controller which does get converted to an entity, and it has this blob asset manage data. Basically, this just keeps a list of all the leader entities, and then in one of my systems, basically I have it so when I push say the 1 key, it's going to associate that with the orange leader. When I press the 5 key, it's going to associate with the purple leader. You can check out my video on blob assets if you want a little bit more information on that. Now the follower entity basically just has a really simple data component on it, which keeps track of a reference to the current leader entity. And you see on the leader data script is a little bit more complex, but basically I'm just gonna have this stuff going on here so it can basically select a random position on the stage. It's going to travel that. Once it reaches that, it's going to go to another random position. go to another random position. I do have a video on this channel about using random in Unity's entity component system, so do watch that video to get a little bit more information on that. All right, so opening up the code here, we have the follower move system, and this is basically going to instruct the follower to move towards the leader. The way we're going to do this is by getting a reference to the translation of the leader. We're going to do that using a get component data from entity. Again, we are going to be calling this inside the onUpdate function. The reason for that is because, again, if any structural changes are made during our code, this will invalidate any references to the component data from entity. So that's why we're just getting it in every single onUpdate here. Now, again, we're going to be looking for the translation component. Remember, this returns every single entity in our project with the translation component. So again, just be aware of that. And finally, inside the parameters here, we're just going to pass in true. Remember, that is the is read only component. That's because we're just going to be reading the translation of the leader entities. We're never going to be writing to them, which again is not ideal. There are better ways to write to components than by using this get component data from entity. Now, you'll remember that this actually returns a component data from entity. So we're just going to go ahead and store that into a variable called all translations. You'll see that if we hover over this, that it is of type component data from entity of type translation. And then we have our reference to the component data from entity. We can actually access that inside our entities.forEach function here. So the first thing that we want to do is we actually want to just check to verify if this component actually exists on that entity. This is the kind of first step to just make sure that that reference is still valid. In theory, if we are getting this every single frame and we're not doing any structural changes, which again would invalidate any references, then there shouldn't be a problem with this, but it's always good to check. So basically what we'll do is we'll just check to see if that component does not exist. If it does not exist, then we'll just return out of the function. So we can just do if exclamation mark all translations dot has component, and then inside here we can just pass in the follower move data dot current leader entity. So here we'll just check to confirm that that entity does in fact have a translation component. If it does not, then we'll just return and move on to the next follower entity. And so now we'll actually go ahead and get the value of the exact world position that the leader is at, and then we can use that to basically follow this leader entity. So just go ahead and do a var target position. We'll set that equal to all translations. So we're going to access the component data from entity collection, and then the way that we key off of the entity is just by using these square brackets here, and then here we can pass in the entity that we want to key off of. So in this case, again, it's going to be the follower move data dot current leader entity, and then at the end we'll just do a dot value. So this, instead of returning the component associated with that entity, is going to return the value of that component. So again, when we just do the all translations and we pass in the key of whichever entity, that's going to return the full component. However, in this case, we only care about the actual value on the component, so we can just do a dot value, and we can store that in the target position. And if I expand this region here, you'll basically see how we use that position, that target position, to calculate the new rotation, as well as basically the step that it needs to take to move towards that next entity. Coming back to Unity, you'll see when I hit the play mode, you'll see that we have all the leader entities just kind of randomly going around however they choose. And then when I say press the number 1 key, it's going to start following the orange entity. And so basically I have it so the color changes to match the current target entity. And then again, I can just hit any of these other keys, 1 through 5, and it's going to start following whichever entity is associated with that particular number. So anyways, that's an overview about how we can get data from any other random arbitrary entity that we want using the get component data from entity method.
Yeah, that's a little bit of a problem though. So like if we use get component I don't know if this is like no. Get wait, what? No. Get component Oh, yeah. Okay. I forget that he's always using system base. On create, on destroy, on update. So I have to look into what the big difference is between these two because I don't think I've looked into it. I system versus system base.
Hello and welcome. In this video, we'll focus a bit on theory necessary to understand how iSystem and system-based work, and when to use which. So let's dive in and learn the interesting details. As I discussed in previous material, systems that implement the iSystem interface operate on unmanaged code, so we have no way to pass references, and almost everything is value-oriented. We have the ability to call methods analogous to mono-behavior, namely onCreate, onUpdate, onDestroy, along with the methods available in the iSystem start-stop interface, namely onStartRunning, equivalent to onEnable,
Oh yeah. Burst compile, no. Unmanaged memory allocated, yes. Garbage collect, GC allocated, no. job with code, yes. Okay. Okay. So effectively, we want to avoid. Okay, so if I do iSystem get another entity's struct, get another entity's get entity data from ID. Get the system handle, and then the system itself with. I don't like that. Get ID. Okay, whatever. At the moment, let's get back to actually getting this worked out. Okay, so we have this, but this is not actually working because we commented it out. I'm debating whether to leave this here or not because like I don't know if updating this like this is the right way to do it. Right? Like I feel like this is the right way to do this. Where did it go? Right. I feel like this is actually the right way to do this. Wait. Where did it go? Did I delete it? There it is. Wait, so I feel like this is actually the right way to do this. Right? And then we want to turn this into a job. Right? And this job here will be the vehicle wheel system job. It does not need world because it does not care about world. Then we come down here. We grab these. Come all the way up here and we replace. Value. Do we need entity? We do not. We use that one, we use that one, we don't use this one, and we do use local transform. There we go. Beautiful. Then we come down here and we make sure that we actually use this, and we don't need the delta time. Actually, no, we do need it, but we don't need it now. We're going to need it eventually. Damn it. We don't need this. We don't need this. We don't need, we do need this. Vehicle, wheel, system job. Vehicle, wheel, system job. Do 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 do. Boom. And we can move this to here so we're not allocating it that way. And it can be all nice and cleaned up there. Beautiful. Then we don't need this. I need to do my walk. So back in 5 to 10. Sounds good. I am going to take this opportunity to grab water. Okay, there we go. Okay, so now what we want to do is we want to up. Are we even applying the force? I feel like the answer is no. No, we're not yet. Okay, so now we have our force. Now I want to apply the force upwards, but instead of being in the center, I want to apply it to each individual suspension. And that way we can see it bend. So I can add a different amount of force to each suspension. So this is supposed to be in linear world space. So math up. So then if I add this as the suspension data, right? So if I grab this suspension data and I do suspension data dot dot no, I need the I need the local transform for the suspension. We don't care about this. So we do care about that the local app. So we'll keep that. Interesting. Fuck off with far. Okay, so to do, we don't need the actual wheel data. We need the suspension front left. And then this will be the beautiful. And this we can do that for now. then here we can do suspension location to do dot position plus there we go. Okay. I wish I could draw. I wish I knew exactly where it was it was applying the force, right? So if I take this and I bring this down here, right? We can do this. There. Then we want to take this and we want to get the front right. We want to get the local transform. Front left, the rear right, and there. And then we want to do this exact same thing to each one of these, but we're going to have a difference in force in each one of them. Right? So then I come down here like this and we get rid of that. Then we do this. This would be front right, and then it would be this plus 100, or we'll say 1000, right? There we go. And then yeah, here we go. So this should give us a bit of a difference in each one of these each corner, if it's hitting each corner. And if not, it's going to be like all over the fucking place. It's not giving us, it's not doing it at a specific spot. Apply angular impulse. YouTube.com. Linear force, impulse verse. Okay. I'm not seeing dropped frames. Play rate's okay to Twitch. Okay.
And then from the physics velocity component, we can get the read and write value. From it, we can access the linear velocity and just increase it based on the direction that we are pressing the keys. So movement.x, multiply this by the speed, also multiply by delta time. On y, we don't want to be changing the velocity, so I'm keeping it just on 0. And on z, it is the same. Back in Unity, just don't forget to put the ball altering script on your player. And now, as I'm pressing WASD, it is adding the force, so even when I let my hands on the keyboard, the player is still moving. And when the player pushes
Mm.
In my previous video, we saw a functioning cannon taking out incoming enemies. There was one thing missing though, the cannon was not inducing any kind of explosive force on the enemies upon impact. Hello everyone, in this video we will try and do just that, add force upon impact. Instead of doing it there, I thought of separating it so we can start clean. Moreover, there is already so much code in there which can get confusing. Here we have a simple scene with a bunch of cubes with a physics body and physics shape. We also have a ground cube that is not affected by gravity, and mainly as we are presenting the cannonball also has physics body and shape. Before we push ahead, I just want to let the simulation run and show you what happens with dot physics. The cubes stay perfectly balanced when using NVIDIA physics, but with dot physics they lose balance. There was a talk about this behavior from Unity. I have a link in the description down below regarding this behavior.
All right. So why does this? There's the 4-wheel, right? Hey, here we go. This is suspension here. Okay, so wait. Yeah, because this is supposed to apply at a specific spot in the world, right? But mine's not doing that. At least it doesn't seem like it's doing that. Could be that it's too much, maybe. So maybe we do 80. Let's just do 80 and see what happens. That's still too much. Let's see if we can tweak this to get like a decent little hover going here. Still too much. I think this is going to be not enough. That's still too much? Interesting. Wow, we were really off. Let's do 10. It's probably because it's like compounding together, so we're actually getting 40. Okay, so 10 was not enough. 15. So 20 was too much, 10 was not enough, so we'll do 15. That's not enough. Let's do 18. We're not going for perfect necessarily. Like we're not going for perfect float, but we are going for a float of some kind. We're almost there. Oh, we're so close. Just a little bit too much. It's not giving us an uneven surface. It says the impulse is in world space. But I don't understand how it gets an impulse in world space. And this also is like the actual like force that's being applied to it. The body position, the body rotation. The body position, the body rotation, the body scale. The angular impulse in world space. Wow, I'm blown out. There we go. That's effectively what I wanted. We could still potentially do a little bit better. We could try 4. An extra 100. I think this will probably give us exactly what we want. But the issue now is that like we're not actually it doesn't appear like we're applying force to the 4 corners. It appears like we're applying force to one corner. Or sorry, into the center. And if the center is what we're applying force to, then it's going to just it's not going to hover correctly. Wow. So 350. And that bothers me because I would like it to not be that way. There we go. This is pretty well correct here. Actually, wait. Sorry. Let's hit play. Just bear with me. Okay, we're pretty well there. What if I go back to my scene? I take this truck and we move it over here. We're still not doing it. It's still not applying it to the... Okay, so we come here. Evenly... Welcome back. I'm trying to figure out why my force is not being applied correctly. I wonder if I need the rigid body. Or maybe the entity itself. Get wheel data. What are you adding force to? I'm adding the force to the rigid, to the physics object. Physics velocity, right? But that might be wrong. Yeah, but there's only right now, currently, there's only one rigid body in the entire scene. Right? And it's the parent right here, right? It's this one right here. Yeah, so like the parent most object. And I'm applying it, and I was under the impression that I was applying it to the um to all the I was applying it to the a specific point on that rigid body, right? but it doesn't appear to be the case. I wonder if I give it a world. See, like, if I give it a world position, it will be completely different. Like the math is completely different because now we're applying something else. Like if I remove these, and I build, well, it will just yeet. So it's applying the force, right? The issue I'm running into is it's applying the force, but it's applying the force in an evenly, I think it's applying it to the center of mass, right? And that's not what I want. I want it to apply to a point, right? So like if I just do it on the left suspension and I hit play, right? We see nothing. And I can get this to float perfectly, right? But like having its sorry, having a different amount on each one of these, it should be giving these points should all be different where it's being applied, but they don't seem to be. Now I could do this. Local to world, right? We could do this and see if this changes it. And then we just remove these ones and see what happens. Yeah, I want it on the edge. Just the corner. Just the one corner. So I wanted to apply the pressure right here. So that should make it at the very least, it should make it topply, right? Like it should have a constant pressure upwards on that one corner. So like at the very least, this corner should be not as close to the ground, right? But what if I do this? Force times 4. What if we just do this? So in non-dots, it's add force at position. Okay. Yeah, that's what I was thinking. Something like that. Yeah, here we go. So we've got enough that it slowly floats down. But like, there's no difference between the left and right here. Even though we're supposed to be only doing it to the one side, right? I wonder, can we do, what are our options here? Ref RW, or sorry, read only. No, ref RW, physics. Wait, what were we doing for the mover? We're using physics velocity and physics dot linear. No. I was thinking maybe angular, the body's angular velocity in a radians per second about each particular axis. But I don't think that's right either. What's up, man? Where did you find that? Oh, unity dots physics mass. No, it's definitely a start. How's the port coming along? Very slow, very painful. Very slow, very painful. Um, distance hit. Add force at point. Dots, unity dots, add force at point. Yeah, no, this is definitely not dots. We did play with dots physics. And ended up coming up with there's a rigid transform. Get linear velocity. Apply dampening. Apply impulse. Wait. Mass. This is a dampening force. Then this is a position, a rotation, and a force. So maybe if I give it a rotation, it will work. But like,
In this video, we're going to look at how to use the new Unity.physics. We're going to check out the various samples and then experiment with all the physics components, do some recaps, and play with events. Let's begin. Hello and welcome, I'm your CodeMonkey, and this channel is all about helping you learn how to make your own games with in-app tutorials made by a professional indie game developer. So if you find the video helpful, consider subscribing. So Unity., if you're not familiar with it, stands for the Data-Oriented Technology Stack. It's composed of the Entity Component System, the Job System, and the Burst Compiler. Essentially, it promises epic performance several orders of magnitude better than working with game objects. For a more detailed explanation of dots and ECS, check the links in the description. Here we're going to look at the implementation of physics in dots. So in this scene here, I have the Unity Physics package installed, as well as the Entities package. Now let's first look at the samples, and then we'll play around with the physics ourselves. The samples are located in this GitHub repo. There's a link in the description, so check it out. Here I have downloaded and opened the project. So over here you have a whole bunch of demos covering all sorts of physics interactions. For example, here the most basic demo is just Hello World made with physics objects. So as we run the game, there you go, the letters fall down, and then we can pick them up and drag them around. There you go, we have a bunch of physics interactions. And if we pause the game and look at the hierarchy, there you go, we have no objects in here. However, if we go into our window, analysis, and into our entity debugger, here we can see all the various letters. And here in the inspector, you can see all of the dots physics components. So in this case, we have the collider, we have some mass, velocity, and damping. So as you can see, you can inspect all of these demos to see how they work. And for example, over here on the last one, we have one of the most complex ones. Here it is, we have some cars and a bunch of objects. So over here, you can see a bunch of physics interactions. So we have a car, and all of them working with physics on the wheels. Then you can see the antennas, which look very springy. Over here on this car, you can see the joints and hinges on the doors. And you can also see the box staying inside. So as I move and I stop, and there you go. And again, all this is using the dots physics package.
Really?
So go ahead and get samples and then inspect all the various demos, and all the code is here for you to learn from. This video is made possible thanks to these awesome supporters. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. Okay, so now that we've looked at samples, let's play around with it. Here we are in an empty scene. Now we want to make a very simple test. Let's make a ball bounce up and down. Now there are two ways we can do this. We can do it using normal rigid bodies and colliders with the conversion workflow, or we can use the dots physics components directly. Let's first use normal rigid bodies. So we do exactly like we've always done. So over here we create a new cube. So let's stretch it out to make it our floor.
I need to really lock in to understand and process what they're saying. Really? I barely need to pay attention.
Okay, so over here we have our floor, and as you can see, we're using a regular box collider component. Now all we need to add is the convert to entity script, and that's pretty much it. Now this object will live as a collider in
the convert to entity script does not exist anymore. Yeah, let's see. We'll drop this cube down, and then we'll try to convert to entity. Yeah. Yeah, but like, I don't know. He speaks a little bit too slow sometimes.
So over here we create a new 3D object. Let's make it a sphere.
Did you know that if you have premium and you watch on a phone or a mobile device, you can get like 4 times speed? Yeah. Yeah, I got the email about it because I have premium, right? And I got that. Oh, I didn't get premium for 4 times speed. I got premium for other reasons. I hate how they lock Q systems to premium. Q systems? What's that?
Welcome to QAQ Software. Today, in this video, I'm going to show you how the queue system works.
No, that's not the one.
To get started with the queue management, you have to firstly create the categories that you are serving to the client. You have to go to the category, then you have to create the categories from here.
Oh, like you can add it to your next okay. You can make a play effectively like this while you're going through the stuff. I see.
And again, it already contains a sphere collider. Now, in order to make it fall down, all we need to do is add a regular rigid body component, make sure that gravity is enabled so it falls down. And again, all we need to do is add the convert to entity script. All right, so that's pretty much it. We set it up exactly the same way as we did with normal game objects. The only difference is we add the convert to entity script. Let's test. And yep, there you go, our sphere fell down. So here we built everything exactly the same as we've always done with the usual components, and just by adding the convert to entity script, all the things get converted into .physics entities. So we can pause and look, and yep, we don't have anything on our game scene, and we have our entities over here in the entity debugger. Okay, so now let's use the .physics components directly. So let's duplicate this and put it on the side. Now over here on this one, let's remove the box collider component, and instead let's add a component. Over here we select dots, go into dots physics, and in this case let's select a physics shape. Now this component essentially merges all the various colliders, so you have a single shape component type.
Is that even an option? I'm kind of curious. Oh. Wait, there's a physics debug display? I have an error in my code. It's right here.
Like the actual shape. So in this case, we want it to be a box, okay? And again, make sure you have the convert to entity component. And that's it. Now for the ball, let's duplicate our sphere, put it on the side, and again, get rid of the sphere collider as well as the rigid body. And now let's add a new component, go into dots, physics, and first we add the physics shape. In this case, we want a sphere. And there you go, you can see the gizmo, okay? And then let's also add a dots, physics. In this case, let's add a physics body. So this is the equivalent for the rigid body. And as you can see, it looks pretty much the same. And again, make sure that it has the convert to entity script. Okay, so that's it for our setup. Over here, we have normal components, and over here, using the dots physics.
Oh, maybe that will fix it. No idea.
Components directly. Let's test. And yep, both objects fell down with gravity. We have one working with normal components and the conversion workflow, and one working directly with the dots physics components. Awesome. Now let's make them bounce. Over here on the dots physics object, in the physics shape, you can see a field for the restitution. So if we set it to 1 and keep the maximum, then this object will not lose any energy. So let's drag to 1 and test. And yep, there's our ball bouncing up and down. Now over here on the normal object, on the sphere collider, we also have a space for a physics material. So let's create a new physics material. Let's call it bouncy. And over here, we just set the bounciness to 1 and combine with the maximum. And then we simply drag our bouncy in there. All right, let's see. And yep, there you go. We have both spheres jumping up and down. So one is using normal components and one using dots physics components. Awesome. Now since we're working with dots physics, that means we're working with the entity component system world. So again, you can see that we're not using game objects. And over here on the entity debugger, we can see all of our various entities. And you can see that both the one that we created with the dots physics components and the one that we created with the normal physics components, both of them have the exact same ECS components.
Like, we don't really necessarily care about a rigid body, right? Like we do, but only in so far as like that we need the physics from it. So if we can get away with not having it, that would
So this is the conversion
that'd
workflow
be
in
dope.
action. Now you can find all the physics components in the package manual. As it says in there, we have all these components that are added depending on if they are needed or not. So if a body does not move, like before, it does not have the physics velocity component. So over here, if I select a cube, there you go, you can look in here and you can see that it has the physics collider and nothing else. But if you select a sphere, and there you go, you can see that it has the physics collider, mass, velocity, and damping. This is another way that we can keep our code nice and performant since it will only have exactly the components that it needs and no more. Alright, now let's write some code to interact with it. Over here, let's make a new C# script, call this our ball jump system. Now in here, let's get rid of the normal behavior things. Instead, we're going to be using unity.entities, and we're going to make this a component system. Alright, now here let's do a simple entities dot for each cycle, and let's cycle through all the entities with a physics velocity component.
It's the raycast.
Alright, so here we can modify the physics velocity. So for example, let's do a simple input.
Triggers.
When we press on the spacebar, let's try to move it up. So for that, we're going to modify the physics velocity, modify the linear, and set the linear y to a certain amount. Alright, so that's it. Let's test. Okay, so here we have our bouncing ball, and by pressing space, and there the entities involved in that interaction and do whatever you want with them. Now over here on the physics sample project, you can go into setup, and over here you have events. And then for example, let's open the portals. There you go, it's the scene, so let's play it out. And yep, over here you can see a different scenario. So the bombs come in, they hit, and they get teleported and moved around, and all of it is working using triggers. Another demo is here, which essentially has 2 triggers that are inverting the gravity. And here in the code, you can see a more robust implementation of the triggers. So you have a job still implementing I trigger events job, then you grab the entity A and B, you try it up, and there you go, just like that, all of a sudden everything is floating. Havoc is paid for. However, right now there's a free trial, so you can play around with it. Here in the physics tab, you can also see, for example, you can modify the gravity. So instead of having it pull down at 9.81 units, let's pull it up. And there you go, just like that, all of a sudden everything is floating. Now there's still a lot more to physics, like joints, hinges, collider casts, and a lot more. I want to keep this video as a simple beginner introduction, so I will leave it here for now, but I will be covering Unity physics more in the future. So let me know specifically what you'd like to see regarding physics. If you want to explore it for yourself, then check out the physics package manual along with the samples included. This video is made possible thanks to these awesome supporters. Go to patreon.com/UnityCodeMonkey to get some perks and help keep the videos free for everyone. As always, you can download the project files and utilities from UnityCodeMonkey.com. Subscribe to the channel for more Unity tutorials, post any questions or have comments, and I'll see you next time. In this video, we're going to look at the current state of
I don't think he goes through any of that. How many rigid bodies? Unity dots physics.
So the feature we're going to take a look at here in this video is physics. Physics allows you to detect collisions, particularly my flavor that I've created in my feature allows you to detect the difference between enter, stay, and exit, and also use like layer masking. So if you want to use the traditional way of marking one particular game object, so to speak, as the player, and another one put them on a layer of enemies, you can tell which layers should detect which layers. So you don't necessarily have the overhead of everything detecting everything. It's quite a nice system. So we'll be taking a look at that today and see just a simple example of one shape falling through another one and doing a trigger detection. And on the topic of physics, we're looking at a Unity dots concept here, which is something to keep in mind that physics in a general sense is deterministic rigid body dynamics as well as spatial query systems, being able to do things like shooting a raycast of where a bullet or a character might go and being able to use that to detect any possible future collisions. That's what a spatial query is here. We're just using deterministic rigid body dynamic system to detect our two objects overlapping.
Wait, what?
And while I might mention this being a physics
I think I spelled that wrong. Yeah. This is paid? I thought Havoc was free. Oh, is it? Okay. One sec. Unity Pro. Or is it plans and pricing? Wait. Oh, that's personal. Wow, you have to pay $200 a month for console. Holy shit. That's fucking insane. The package brings the Power of Havoc physics to Unity Dots framework. It builds on top of Unity Physics, the C# physics engine written for Dots by Unity and Havoc. Preview package. The use of Havoc physics for Unity is subject to a specific licensing model. The license and distribution model for Havoc Physics for Unity is owned and managed entirely by Microsoft Havoc. Wait, Havoc is owned by Microsoft? When the fuck did that happen? In 2007, Intel acquired Havoc. In 2008, it was honored at the... In 2015, Microsoft acquired it. Okay, Havoc Physics for Unity is free to download from the Unity package manager. Using the features at runtime may, however, require the development license depending on your Unity subscription plan. Unity Personal, free. Unity Plus, free. Unity Pro, Havoc Physics for Unity subscription is required, available in the asset store. That's... I feel like it's trolling me. It does. It does sound like that. That's the thing. It sounds entirely like you can use it. As long as you're not on the better simulation performance. Havoc Physics for Unity is a stateful engine, which means simulation times is over 2 times faster than Unity physics in scenes that have a significant number of rigid bodies. This is due to the automatic sleep and interactive rigid bodies and other advanced caching techniques. Higher simulation quality, deep profiling and debugging, and Havoc Physics in Unity for Unity, and Unity physics is similar but not identical. If you have finely tuned your simulations using Unity physics, you may need to retune for Havoc. I don't mind using it. I'm just really curious, depending on like how much it's gonna cost. Like I'm not gonna pay for it right now, right? But it's like it's something that I could theoretically get behind. Havoc Physics for Unity is a binary only distributed by Havoc Physics that has the same industry standard power but without access to C++ source code, known as a base and product access or direct support from Havoc. And then we click on this license and it tells us nothing. This package provides... Yeah, it tells us literally nothing. Package documentation. Still... Yeah. Oh, wait. What the fuck? Ow. I think they hold it off to make you upgrade. Yeah, but their packages say that you don't need to upgrade. That's the weird part, right? Havoc for Unity. Our products are valuation. Contact us. Havoc navigation. It looks like it's going to be ungodly expensive because it's a contact us. It's straight up like reach out to us and we'll talk. But yeah, like it's free to use on Plus and Personal. Pro you have to, but it says it's from the Unity Asset Store. Unity Asset Store. That's what's not in the Unity Asset Store. Maybe it changed. Maybe it's just free to use now. I mean, this is being applied to in a fixed update where it should be, and not the normal update. It won't matter. It's just the same as multiplier to shrink the force. Get it to apply to a set point, but the object is reacting as if it's being applied to the center of mass. But the object is not rotating when I'm flying to only one corner. Supply linear impulse. The wrong one to use. I think it might be. Yeah, I think it might be. I think we need the apply in impulse from world. Unity is canceling the runtime fee effective immediately. Wait, what? It kind of feels like they actually are just giving this away now. To do was available in the personal and plus license holders has been deprecated. We shared this update on the now deprecated asset store page. Direct email to purchasers of the Havoc Physics experimental package, as well as in this forum post. That being said, if you need continued access to this experimental version, please let me know. Interesting. The full version of Havoc Physics for Unity is now included as part of Unity Pro, Enterprise, and UIC subscriptions. This is a shift from our previous distribution model where users had to pay a monthly/annual subscription fee to access it. We believe that bundling Havoc Physics for Unity with Pro, Enterprise, and UIC subscription provides more value to our users. We're always looking for whatever. You still pay. Oh, you pay shit tons. It's $200 a month. Holy fuck. Well, that's one thing that we're definitely not doing. I feel like we need to get the rigid body. I think that's actually what we need. I think we need the rigid body. I think we need the rigid body index. Get my rigid body index. Can I just put maybe this? Wait. Can I do this? One sec. Ref RO. Rigid body. Can we just do this? Is this correct? What's this complaining about? The answer is no. The answer is get lost, apparently. Though if I remove this, right, we come back into Unity itself, right? And clear this. Do we still have an error? Yeah, we do. Okay. It's right here. Then I might be able to add it through the rigid body index, whatever, right? Okay, if I world index of 0. the index of the physics world the rigid body will be associated to. That doesn't seem right. I feel like we're not gaining anything from that. It didn't look like it. Because I didn't see anything new. Okay, so here's our current stuff, right? No, okay, so it was saying that you can associate it with a specific physics world, right? But we're not, we only have one physics world. Yeah. Because it wants world, right? So like it wants the physics world. No, physics world. Like if we can use the physics world, right? I think the physics world has a thing for us, right? So if I use this has dot apply impulse, right? And then this takes in a rigid body index, an impulse, and a point. And that point is the spot that it's supposed to do it on. But then we need a rigid body index. Get the rigid body index of the current entity. I want this to be, if I pass in, if I can get this to actually accept entity, then we're golden, right? But I don't think we can do that with the access. Oh, we did it. We did it. Fuck yeah, I did it. Okay, so this takes in the chassis entity index. This might work. This might actually work. Okay, so add impulse, right? The point is in world space. And we've got our linear do. So then we can remove this position altogether. We can just do that. And we can move that to here. And then this is the force vector. And we can see if this works. There's like at least a 50% chance that this does the thing that we want. If it just falls straight down, that's fine. Yeah, okay, that's fine. We might need like extra force. Okay, so apply an impulse to a rigid body at a point in world space. The point is the world space. The linear impulse is the impulse itself. Okay, so let's make sure that we're actually getting a chassis index. I don't care if we have to multiply it by 100,000 extra. Like I don't care how much we have to apply more. I might actually just make this thing a little bit less weighty. Let's actually do that. Let's just put this down to 10. This should fly now, right? No, it doesn't apply the physics. What the actual fuck? God damn it. Come on. Draw colliders? Enables debug display colliders. Draw contacts? Enables a debug display of the context directed narrow face. Collision events enables the debug display for collision events, trigger events, joints. Let's see what happens. Nothing. It's stupid. Body position? Maybe use the apply at world space. Do you think because we're applying it to itself that it needs local space maybe? One sec. We're going to try this real quick. And then if this works, we'll be happy. And if it doesn't, then it doesn't work. It doesn't seem to work. Sorry, the last thing I was working on, or sorry, the last thing I was looking at. So this one? No. Before that. Give me a second here. We're just it was probably this one. These were the only two that I was like looking at here. It feels like this is the right one. Uh, oh, wait. Value, read W. Oh, I think it was this one. But that's Angular. So we have to do the body position and the yeah, okay, so the body position, the body rotation. I'm assuming this is the position and rotation of the body that we're applying it to, right? So let's try this. Okay, so we do the physics mass dot value read write. Then a float 3. Wait, this isn't it. One sec. Okay, so the physics mass, a float 3, which is T, which is the body position. Wait. T is the body position and it's a float. Oh yeah, float. Sorry, float 3 is a position, right? Sorry, this is local, or sorry, local to local to world dot position dot value read only dot position local to world dot value read o dot rotation. Then our force vector, which is force vector. Then our the location at which we want the impulse to happen, I think. Oh, wait. I was looking at this wrong. Okay, so there's our force vector. But this is probably the location we in the world space where we want it to be applied, maybe? I want to check something though. Physics mass, the body position. I think we found it. I think it's one of these. Yeah, okay, so we need the location of the object itself, and then the location that we're applying the impulse at, which is so let's do suspension front right dot position. It's like a hard maybe. So physics float 3 quaternion. Does this need to be a read write? My local to world is read only, and I think we need this to be read write. Local to world dot IU read only dot position. This is a float 3. This requires an in for float 3, and an in for a quaternion, and then an impulse, float 3 impulse. Yeah, these values should all be correct. It helps when I do it right. There we go. You know what? The answer is not to be an idiot like me, and then things work more often. Okay, let's hit play and see what happens. Well, it applied the impulse. Boy, did it ever apply the impulse. We're getting somewhere here. Oh, right. I forgot that I made this like really light. It worked. It worked. Oh my God, it worked. Did you see it? Did you see it? Did you see it? Look. I finally figured it out. It is front right. Yay! It was slower on one corner. Exactly. Exactly what we wanted. Front right. Okay, so now we want these all need to be local to world. There we go. Then we're going to rename these. It's beautiful. It's so interesting. Someone used helium in the time. Those would be that'd be an expensive way to do tires. One sec, I'm just gonna do this. There we go. God damn, it works. Look at that. Ship it. It's beautiful. Now learning to fly, it has fly. It is going to be interesting. Learning to fly it is going to be interesting. Yeah, fuck it. I don't care about learning to fly it. Fuck that. I'm done. The rigid body system does not The rigid body system does not like me. Sorry, my headset fell off. Say that again. The rigid body system does not like me. Rigid body physics are stupid. Fuck them rigid body systems. They can go to hell. Go to all the hells. All the hells. Okay, let's see here. So I think what we might want to do, actually no, because we need the position to constantly be updating, right? So I was thinking that like maybe we could get away with not using the entity here, but we still need those entity data points, so it just doesn't work. There's so much here that we can get rid of. We're gonna make this so much lighter. The vehicle wheel authoring data. Wait. This is the wheel. I'm gonna leave that for now. Yeah. It's this one here that we don't need so much stuff with. So we can get rid of a bunch of this stuff. Get rid of this, that. Don't need it. We can get rid of these. Don't need them. Get rid of this. Drop this. Don't need it. Oh, the entities are grayed out because they're not being used yet. Yeah. Okay, so progress. So why is it all over the fucking place like that? I wonder what happens if I come back to this chassis and we get rid of the box and we give it the actual mesh collider. And we hit play. What happens? So apparently the front wheels need to be less. And the up vector is a bit weird, right? Like I feel like that's wrong. I feel like our up vector is wrong. Wait, do I actually still have it as math.up? Yeah, you're right, I do. RF vector is horribly wrong. Local up. This is what we want. And because we're doing that, we don't need... Oh, this is gonna be beautiful. It's gonna do a thing. We're probably about to go flying. It's probably just gonna go boom. Super high. Rocket track? Yes. Straight up. The most up. Okay, we hit play. One, two, three, yeet. Feel the yeet. 0.1. We'll tune it better later. I'm just kind of curious. Yay! Wee! Okay, so all we have to realistically all we have to do is just do this. This is probably like let's try a much smaller number. I feel like much smaller numbers are correct. The correct answer is small numbers, not large numbers. Not yeety numbers. The yeets. Let the yeets begin. There we go. So the front is lighter than the back, likely due to our center of mass. What is like... Yeah, you see it, right? So we're applying here, and our center of mass is here. So we need to change that. Get the difference between the center of mass and the center of the... Oh, this needs to have the chassis. do. The difference between the center of mass and the center of the Actually, yeah, I guess that does make sense. So we don't actually need the chassis because we have our current location, right? And it's going to be relative. So all we need to do is do center of mass equals authoring center of mass. And authoring dot. And then this is a rigid, I think a rigid body, right? Rigid transform, yeah. There we go. And then I want this to be a local transform, not a rigid transform. There we go. Then when we come into here, we can do this. Instead of this being local to world, right? We can do, actually, wait. It's local to world plus vehicle configuration dot value read only dot center of mass dot position. And then we can leave the rotation. It doesn't matter for now. Okay, and then we take the center of mass. And we hit clear. We hit save. Wait. And then we have to do this. We have to do this. Wait, it's not that one. It's this one, and it's apply all. There. Do I have an error? No, wait, what? What's the goddamn problem? Vehicle wheel data. (44) in wheel data? 4317. There we go. Beautiful. Did you see that? See how amazing that was? What's the issue? Object reference not set to an instance of object. Oh, right. Look at that. No more error. Okay. And now if we go back to the center of mass and we offset this back a bit more and we hit play, it works. It works. It works. Yes. What if we do that? Yeah. Do, 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 do. It's beautiful. Or organal Nell 23. Thank you for the follow. So I butchered the fuck out of your name there. Yeah. Oh wait, that's not what I wanted. This is what I wanted. Oops. Yeah, I butchered that real bad. Okay, wait. Which way is it going again? Is it going forward? It's going forward. Okay. So if we move this forward just a little bit. Keep going forward. We're gonna hit a center of mass where. Oh, look at that. Oh. We're making progress. It's beautiful. What is it? It's the z-axis, right? We're still making it's still a bit too heavy in the front. Oh, wait. That's because I'm going the wrong way. There we go. Let's do 5-9. Nope. 5-8. 5-8-5. 5-9. Five, 9-1. There we go. It works. It's beautiful. It is actually lighter on one side. And then if I do this overrides and apply all, there we go. Beautiful, beautiful, beautiful. Oh my God! Look, it's lighter on one side because we don't have symmetry. It's not perfectly symmetric. Oh, I don't care that much. The vehicle's not finished, right? So if we look at it, right, like there's going to be one of these on this side, right? So I just have to wait. For testing. I need the symmetries. The symmetries. I could import a different model, but I might as well work with the model that he's going to give me. In the meantime, we have liftoff. We can make shit work. Now what we can do is we can tune. Now we need to do is tune how much force is being applied. Right? Because like if we're not hitting anything, we shouldn't have any force applied. Right? So now is the raycast stuff. Oh my God, I'm so happy. Okay, so now we shoot a ray down to see where we're at. You know. Really listened. We have the thing working. Okay, so we'll do it locally. I talked to him and that's pretty much what he would just cut it down the center and mirror it. So we're gonna do the same thing. So now we need to figure out now we have to do the hard part. The hard part is going to be figuring out the hard part's going to be doing the upward force based off of the spring. Cuz yeah, we hate life. Okay, so youtube.com.
I need an angel, saved from myself, holding my savior, keep my heart from the shell. Do you remember the things we said, the things we felt? Call me forever, for every passing moment we left. I need an angel to save me from my fate. I need an angel to let me stop along the way.
That's kind of neat. I also don't care though.
About things like our offset and our velocity.
Compression ratio between 0 and all our ray points. Following that, define a layer mask called drivable. This layer carves this at the rest stretched. Let's break down what each of these variables mean. Rest length is the standard length of our theoretical spring when it's not being compressed or stretched. Spring travel is the maximum distance our spring can either compress or extend from its normal position. We will use this to calculate the force to apply based on how much the spring has compressed or extended relative to this maximum travel distance. Spring stiffness represents the maximum force our spring can exert, which occurs when it's fully compressed. Now let's take on the suspension logic. Start by creating a function named suspension. Inside this function, declare a raycast hit variable named hit to hold data from the raycast hit point. Then, introduce another float variable named max length, which represents the maximum length of the spring, calculated as the sum of rest length and spring travel. Next, wrap all these operations in a for each loop, since we need to execute them for each ray point. Thus, for each ray point in our ray points array, we'll apply the following logic. Use an if statement to shoot a raycast from the ray point's position in downwards direction. Use out hit to store the ray's hit data. The ray's travel distance should be the max length of the spring plus the wheel radius, ensuring the ray covers the entire length of our suspension components to be able to reach the ground. The raycast will check against the drivable layer mask to determine valid surfaces. Now, let's create a float named current spring length to figure out how much the spring has contracted from its resting state. To do this, we'll subtract the wheel radius from the hit distance, which gives us the current length of the ray. When the spring is in its resting position, this calculation will be equal to the rest length, which we're using as the spring's length. Next, introduce another float named spring compression. This variable will hold the current compression of the spring, so we can apply force accurately. It's calculated as the rest length of the spring minus the current spring length, showing how far the spring has moved from its rest position. Finally, we divide this by the spring travel to scale the compression ratio between 0 and 1, enabling us to understand the spring's compression in a normalized manner. Create a float to hold the spring force, calculated by multiplying the spring compression by the spring stiffness. This represents force required based on the spring compression. Next, apply this force to the car in an upward direction.
Give me 1 sec. I'll be right back. Oh my god, it's cold. Come on, fix the green screen. Right, I don't have the preview. There we go. Green screen fixed. I just realized that it's like 4:30 and I still haven't eaten lunch. How's everybody doing today? Okay, so pass Unity dots job fetch data of entity of attached entity. Okay. I see what's going on here. Okay, so from the job component system. Welcome back. That's not what I wanted. Can I wonder if I can have multiple box colliders without having too much problems. I think I can, but I don't think that you can do it on. Yeah. Hmm. The real answer is to provide a mesh collider for this. The perfect mesh collider. Like I could, but I don't know if I want to. I'll show you what I mean. Right? And then all we do is we add a box. Vertice. We turn on there. Then all we do is we go like this. We extrude face. Like that. Just bear with me real quick here. Yeah, we're just going to make a super simplified shape. Do, 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 do. There we go. Okay, so then what we do is we go like this. We don't need those lines, right? They don't mean anything. Those lines don't mean anything. We got to keep these ones. But we can merge them together and we can actually do this, right? So we do that and then we delete edges. And we do that and we delete edges. Need to keep this one. But we can do this. Um, Kun Kunalai thanks for the follow, much appreciated. Is this why GTA 6 takes 20 years? 20 years? Yeah, totally. At least you understand. There we go. So in a situation like this, we do need tries, right? We want everything to be a triangle for this. Since we've largely finished up the actual like setup, we can just try everything here. Everything's a triangle. We could actually do this edge. Let's do that actually. We're gonna delete that. Actually no, we're gonna leave that. I want to have that there be like that. So if I go like that, now we see this, right? It's all pretty. And then all we have to do is we can go like this now. And that. There we go. Now we have a bit of a different wheel well there. But honestly, because we've got this coming down like that, I feel like maybe we should bring this down and flatten it out a bit more. So it drags a bit more. Actually, you know what? Maybe we want to change that a bit. Give me a second. Yeah. There we go. I think I actually just want this to cut over like this. That way this is flat right here and we don't get caught on things as easy because I don't want to add extra geo there. But yeah, effectively we could do that. The other option would be to just jump into Houdini. I'll be right back. So what we actually want to do probably, this is just going to be the easiest. So we just drop this in. This is not the most amazing way to do this. Arguably almost a bad way of doing it for the final project. I think for the final project, we should have our own custom, like fully custom, low poly vehicle for it. There we go. There. And all we want to do is we want to add symmetry. Hello, how are you doing today? I'm doing good. Still needs work. Welcome back. Houdini is Houdini. Hmm. This is a problem. There we go. Now we just do FBX output. There we go. Now, if I come into here and we go into meshes, this should be a drop-in replacement mesh. But it's hard to say whether or not it's going to be a drop-in replacement mesh because it might be oriented wrong. My girlfriend asked, "What is he doing?" What should I say? I'm updating things. I'm fixing my track. I was fixing the symmetry on the truck. Look at that, it's upside down. Mhm. Okay, so it's not that. Super upside down. It needs to be 180. And then 180. No. Then 180? Yeah, there we go. That's not correct at all. Look at that. It came in correctly that time. Perfect. So now I can be a drop-in replacement. So now if I go to the chassis and we do prefabs, we open up Truck-Kun dots, go to the chassis, come up here to mirrored. We take this, we do that. We see that this is wrong. We give it a nice rotation of 180 of 0, and then we do 180. We get the right shit there. Beautiful. There we go. And then we go back to the chassis. And then we recompute there. Game developer to dive in deeper and learn parallel programming. As a game dev? Yes. Why wouldn't it be? Oh, that's why. There we go. If I should take the study further than my class and invest a lot of time. It depends. So I say it depends because it does. It depends. Okay. You will need to know parallel computing. If you want to do, okay, so if you want to do game dev professionally, parallel computing is a must. You don't really have a choice. And that's the answer. Is parallel computing the absolute most important thing for your game dev career? It also depends. Where are you right this moment? Right? Why did that go that way? Why is my center of mass fucky? Like, what? Oh, okay, that's better. No, it's still on one side. I guess it's just like unfortunate, right? Because it's deterministic. So like it is falling. And so I guess it has to make up its mind on which direction it's going to go once it falls. Because there is a point right there, right? So it's not that it's not that there's an issue so much as, well, there's an issue, but the issue is that like it's not quite what we want. Yeah, whatever. I have a feeling that won't cause any problems. Just because like I think that it's a happenstance of as it falls and then it has to make up its mind and it's a bit random. But because the seed is always the same number, it makes up its mind in the same direction every time. If I move it, it might give me a slightly different answer. Yeah, it was right. No, yeah, it eventually falls to the left. Interesting. Is there a program or application like LeetCode that you know that can have me? Do you know what LeetCode is used for? Like, do you understand that? Creating algorithms? No. In your day to day, you never use you will never actually use LeetCode at work. When you go to work, you will never use LeetCode. The concepts, the general concepts, you'll use, right? But that's about it. LeetCode is just an interview thing. That's all it is. Outside of that, it's useless. Like, don't get that wrong though. Like, if you don't understand any of the concepts of LeetCode, then doing LeetCode will solidify those concepts for you. And those concepts are good to know. They're not actually required, right? Yeah, like I was going to use it to get stronger in algorithm development for myself. Yeah, like LeetCode is useful. It has a use. It's just like if you really want to learn parallel programming, right? Like if you really want to break down and learn a topic, LeetCode systems are not the way to do it. Right? Like if you really want to go deep and figure out binary tree you would be better off. Like if you want to learn these concepts and really figure them out and like when you would use them and stuff like that, because that's more important sometimes than actually learning how do I build a binary tree from scratch, right? Is when do I use a binary tree? You want to build things. Building things is more important than LeetCode, right? LeetCode is useful to get you a job. Building things is useful for keeping a job. Building things teaches you actual real world problem solving, right? Like, do you give feedback on games here? I'm making a mobile game and would love some feedback. Not really, but is it in the App Store? I thought LeetCode was going to help me to see what algorithms were more efficient than others. Sure, if you want to link it, we can take a look at it. I thought LeetCode was going to help me see what algorithms were more efficient than others. It will, but it's in the context of what the problem that you're solving, right? So, okay, so if I have a problem, right? And there's usually going to be multiple ways to solve the problem, right? Here is time, right? Or okay, so you have the number of units, right? The number of times that it needs to be done, and this is going up, right? And then this is the complexity, or like the time on your CPU, right? So this is CPU time, and this is the number of times that it needs to be repeated. Okay, so there's some algorithms, right, that are really good at this, right? You have a very low number, and they come in like this. But sorry, they come in like this. Like some algorithms will be like this. Some algorithms will be like this, right? Some algorithms will be like this. And then other algorithms might be like this. I picked really bad colors. Let me pick better colors here. Okay, so you'll have algorithms that come in like this. You'll have algorithms that come in like this. Yeah, you'll have algorithms that come in like this. And then in some cases, like you'll have algorithms that come in like this. Okay, I have a question. Which is the best algorithm from this chart? Which one's the best? Is one of these best in every single situation? Or is there some that are better in some instances and others that are better in others? No, it's not. O1 is not the right answer. The answer here is if I have this many number of times to do something, this one's the right answer. Right? if I have to operate in this space, this one's the right answer. Right? Then there's another question, right? Because anytime you performance optimize, when you performance optimize something really intensely, your code becomes worse. Your code quality is worse, right? You can keep up really good code quality for high performance code, but really high performance code is not super legible, right? So then you've got to also weigh out how much time is the rest of the team going to need to dedicate every time we come across this code to remember how to do what's going on here, and am I capable of documenting it to a point where in 3 years I can come back, spot read this code and work on it, right? Like there's so many things that you have to worry about in real world situations. Micro optimizations are not the way you're going to, they're not super efficient ways to do it. Obviously, if you're working on like this many objects and you're using the wrong algorithm, that's a huge deal, right? Like this is like, let's say this is like a 10 million operations here, right? We're 10 million operations in this area right here. Like this is 10 million operations. If you have to do this and you do this all the time and you're using the wrong algorithm, this will tank your performance horribly, right? Like it will just destroy your system. And going to this will be better, right? But some things, even though they're less efficient at high usage, they're way more efficient at low usage. So you need to know all of them to pick the right one, right? But like again, it comes down to like how often is it being used? Because like the difference between this one and this one at maybe like 10 units is like fractions of a fraction of a fraction of a fraction of a fraction of a nanosecond, right? Like it doesn't matter which one you implement. They both do the same thing. They're both roughly about the same amount of time for the vast majority of things that you're going to do, right? Because the vast majority of us are going to work in black box systems and where it's like some enterprise person, so it's like we're building software for enterprise users, right? Where it's like they run it and they're the only people that use it. We're maybe running for like a couple hundred people, right? So like it doesn't matter that much, right? So it comes down to so many different things that like LeetCode doesn't teach you why you should be using something. It teaches you the different options that are available to you, right? And it doesn't teach you when you should be using it. And the most valuable thing that you can do is, when should I use X? When should I use Y? Why should I be doing X, Y, or Z, right? And the best way to learn those things are by doing it. You just got to do it. It's the only way forward, is just do it. You just push forward, right? You find a project and you go run with a project, right? Where the fuck did that link go? Oh, there it is. Here, link. So if you want to do game dev, right? And it kind of sounds like you want to. I would suggest building a game. That's where I would start. Why is that link not in the right spot? Okay, let's take a look at this. Can LeetCode be a type of starting point, or is that just a waste of time? No, LeetCode is useful. Like I said, LeetCode gets you your
Welcome
job,
to Fit.
right? Yeah. LeetCode becomes less important the more senior you get. This is like a Fitbit based game or something like that. Doesn't look like we're gonna get in trouble for this.
Welcome to FitQuest, where your fitness journey transforms into a thrilling cyberpunk adventure. Let's create a guest account to get started.
I don't like the voice. No offense to the person that you if you got somebody to voice this for you, I'm sorry, but they sound like AI. Yeah, no, it makes me already suspicious of the app.
Started. We will also need to customize our character. This is the homepage, where users can track their progress, start their workout, and see their character. Your character has 6 courses.
That's fine. I'm just letting you know. Right? These are just my notes.
Stats that grow through workouts and equipped items, boosting your effectiveness in dungeons. Let's start a workout. All exercises are organized by muscle group for quick selection. Now just enter the number of reps and the weight done. Once you are done with the workout, click N to save your progress and update your stats. Congratulations! You gained 2 points in strength, agility, and speed. Here we have the chest page, where users can buy chests and get items. Stats of each item will be shown next to it. Let's try selling some of the items we just got from the chest. This will put our item in the global market for other FitQuest players to buy. Hopefully. Someone buys it. Let's move on to the dungeons. This is the dungeon menu, where you can choose the difficulty of the dungeon you want to go to. I will go with the easy one for now. Once you start a dungeon run, your character will automatically navigate the dungeon, collecting items, coins, and battling monsters. Occasionally, named NPCs will appear to pause the session and prompt you to make important decisions with lasting consequences. Each named NPC is procedurally generated by AI with a detailed personality and specific likes and dislikes. These NPCs aren't just static. They have dynamic reactions based on your choices, making each encounter unique. Can you need to put something up that shows me what these unique AI enemies are, the named enemies or whatever, because right now it's really meaningless. With yeah, like it's an interesting concept. Additionally, all dungeon events are logged in the dungeon log, providing clear explanations into your adventure. Watching your health is critical. If you die, all collected items are lost. Although there are
wait, so like when I run into like a named NPC, do they give me a task that I then have to go and like fulfill or something like that? Is that what that is? Like, what do they do? I'm confused on that.
Events which can heal you. We recommend exiting the dungeon if you are running low on health. We made it out of the dungeon safely and collected all the items. Let's equip some of them and boost our stats.
If this is entirely hands off for the dungeons, then how do I leave the dungeon? Right? Like, how do I know when I should be leaving the dungeon? Do I get like a push notification when my health gets low or something like that? Or do I just need to constantly be checking the app? Concepts there. Concepts work there. I'm sure that there's a lot. There's definitely probably a market for that. But yeah, I don't understand it fully yet. I just blue screened. Oh, I am sorry to hear that. So I think we collectively agree that there's the concept's there. There's definitely something. It could turn into something. Right now it is not that. The AI you need to explain the AI named AI system a bit better. And I want more details about how the dungeon system works regarding like leaving before I die and stuff like that. Initially, it sounded like the dungeon setting thing was just like set it and forget it kind of thing. I come back and I've completed it or whatever. Maybe I do that once a day or something. But then you're talking about like leaving the dungeon when my health gets too low so I don't die. And it's just like, yeah, but like, how do I know that yeah, I was thinking more of like an idle game, so then it wouldn't matter. And it's just like, so how do I know when to leave the dungeon? Do I get a push notification? Do I have to constantly be monitoring? Like, I need to know that. It sounds very hands-on for what feels like it would be an idle game. Coupled with like the workout system, right? But the idea is interesting. You've definitely got something. Really, interests, likes, dislikes. This stuff is sent to the AI, generated prompt has a good option and a bad option. The option gives you items, coins, etc. So does it stay there forever? Right? Like as until I come back to the app? Because this feels like an idle game. But okay, and then about the health, like how does that work? Do I have to constantly be monitoring? Does it pause after every fight? To wait for me to say keep going, or does it pause at a certain percentage health, right? Where I could die at the next fight to let me know, hey, maybe you might want to leave. Do I get a push notification? Right? Like anyway, so that's kind of my question set there. Where are we at kind of thing. I gotta figure out why is it off? This should be completely symmetrical. So why do I always go to one side? Where's my center of mass? Where's my center of mass? Right there. Center of mass is 0, 0 on the XY. You have to constantly monitoring. If you reach 0, you lose items collected. Get a notification at 10%. Okay. It personally, an app like this, I wouldn't want to monitor all the time. So if you're gonna go with the whole fitness thing, I would suggest taking out the manual leaving of the dungeon and either make it a roguelite system where you fail and you start over. That's fine, right? Like where you accumulate as you fail kind of thing. Or you have it auto eject you at 10% or whatever. Yeah, sticking to the workout schedule could be a good way to do it because like you're trying to incentivize the workouts more than anything, right? At least that's my thought is that like this is to incentivize gamify your workouts, right? So I'd tie right now. It seems like the workouts are kind of like secondary to the idle game. That's not really an idle game, but kind of an idle game, but not an idle game, which feels weird because aspects of it are idle, and then there's aspects of it where you have to constantly be monitoring. So okay. All right. It is 5:20 and I've been going. I think you could do what Vampire Survivor has to and have a type of animation reward. You kind of want to make it like a gamble because there are events that heal you. Yeah, but like if you're workshopping this, right? Okay, so if you're workshopping this, you need to figure out what the core concept of your game is, like the core of your game, because everything else is immaterial to the core concept of the game, right? So so for example, right? There's many parts to this game that I'm working on, but the core concept of the game, there's only one thing. You are truck, right? There you are, truck. The entire point of this game is to run people over to save another world. That is the entire point of the game. If I do not have this mechanic in the game is not the game. Now, I can add to it and say, hey, to add a challenge to make the game more fun, we will have NPCs that you are not. Oh, fucking ads. Hey, I just missed it. Did it work? Did the dismiss for the ads work? No, it's ad in progress. Fuck. The 20 Somebody gifted a sub. Thank you for the anonymous sub gifting to Bob Ronio. Rona. Yeah. Okay. So everybody should be back now, right? Yeah. Okay. So the core concept of my game is you drive truck, you run over target to save other world, right? But really the core concept of the game is you drive truck, you run people over. That's the core concept of my game. Everything else is fluff, filler. It might make the game more fun, but it's filler. If I don't have this concept here, I do not have my game. So this is core concept, right? I want pedestrians that you are not supposed to run over. I want other cars on the road. So other trucks, other or sports cars or whatever, right? These obstacles make game more fun, right? Core concept, run people over, right? These are not required, but they make the game more interesting, right? Do I need a city for my game? No. Do I need it? Do I need a city to make my game feel more fun to drive around in? Yes. Right? But the core concept of the game is run people over. No, I'm saying that everything except you should focus on your core concept, right? And then you build out with things that are more fun from there. Because you said that you have events that happen that give you health back, right? But like, is health meaningful, right? Does having health and losing health make the game more fun, right? Is that something that engages you to and makes the game more interesting and more fun, right? Or more sticky, right? And if the answer is no, if it's not a core part of the game, then you rip it out because it doesn't matter. It doesn't matter if you spent 6 months on that one part of it, right? At the end of the day, you shouldn't be afraid to cut things out of the game or any product. This holds true for any product, right? You should never be afraid to cut things out of the product unless it actively destroys the product, right? And when I say actively destroys the product, I don't mean when I say that, I mean like if I removed any part of this, the game would change, right? And and then it wouldn't be the game anymore, right? So like the health system sounds like it's immaterial to the game, right? So whether or not the health system makes the game more fun or not is kind of like up in the air. We don't know, right? But it seems like a lot of extra is being tacked on to make the health system viable. But my question is the health system a core concept to the game, or is the workout system the core concept and you're adding to it to make people work out or give them a reason to work out, right? Because like the workouts improve your stats, and then you're trying to bolt on something that gives them something to do with those stats, right? And maybe more exploration into different things that you could do with your stats is the right way to go, right? Or maybe the health system is the way to go, and I'm wrong, right? Like that's also possible, right? But don't be afraid to scrap something even if you've spent a lot of time on it, right? Even if you have a lot of different systems that feed into something, if you find that it doesn't actively make your game more fun, don't be afraid to scrap it. I'm not saying scrap the health system. I'm saying I don't understand why the health system's important. Sure, but you don't need a health system for that. Like you don't need a health system that like destroys things for you, right? Like if the concept of this game is to get me to work out with it, and you could do a complete idle game around it, and that sounds like it'd be great, because I don't want to be interacting. Like to be fair, I might not also be your core audience, right? So that could also play into this. But so take everything that I say with a grain of salt. But I think that personally, I'd be more entertained by this game, if it was more focused on an idle game for what you do when you're not working out. Right? So like if I'm not working out, maybe it becomes a traditional idle game, and the only way to increase my stats is to do the workouts, right? And the whole like trading system and buying and selling system, I don't really understand why that's important. But it is what it is, right? Like that could be something where it just takes you utilizing the app to really understand why it's there, kind of thing. But there's a bunch of ways, right? But I would suggest take a look at idle games and roguelites. Roguelites are probably your best roguelites, and your idle games are probably going to be the best ones to model your game after. If you want to go down the route that it feels like you want to go down. Maybe. I don't know. I don't know what's going to be the right answer. Oh, there's a bunch. One of the ones I played recently was like a claw game based one. Yeah, Dungeon Clawer. This was cool, right? So you go through and like you do these battles, right? And you play a claw game to do the battles. And then at the end, you get permanent upgrades, right? And it's really cool. I enjoyed it. It's definitely like one of the ones that I liked. But there's so many examples of roguelites. This is a really popular one. Darkest Dungeon. Darkest Dungeon and Darkest Dungeon 2. Although Darkest Dungeon might be the better one to go for. Darkest Dungeon, yeah. Darkest Dungeon's a roguelite or a slash roguelike. I can never remember which one's which. Really popular, really good. Let's see. But the idea of a roguelite like system is like you die, you're supposed to die. And then you respawn. Hades is another one. Hades. This is a really popular one right now. So you die multiple times over and over and over and over and over and over again. And every time you die, you increase your stats. Right? I don't know. I think personally, I think that the idle game is probably a cool system. Idle Heroes, I think it was. I totally spelt that wrong. Idle Hero. I think it was Idle Hero. I want to say that it was Idle Hero. There was an Idle Hero game that me and a couple friends played because you could play as a group together, right? So we played it, and then you just effectively like left your computer on. Oh no, it was Clicker Hero. Yeah, this one. Right? You just effectively, it's an idle game. You get to like you engage with it a little bit at the beginning, but you get to a point where you're just prestiging to destroy things, right? And it's not too bad, right? But there's a lot of the Cookie Clicker is another one that you could use as a jumping off point. Mr. Miner, like there's lots of these ones. Because these all have the effectively a prestige system. So no, I'm saying that I'm confused at I'm what side of it is your core? I want to say that the workout system is your core, and everything else should feed into that or feed from that, and your main focus should be around making sure that like the people want to come back to the workout side of it, right? So like the whole like dungeon system with the health and the dying and losing stuff and me having to constantly be on my phone doesn't interest me, right? Personally. But that's a personal thing, right? Well, it depends, right? Like I don't really know the full aspect of like what you want to build, right? I can guess, right? Maybe I'm wrong, and maybe you don't care about the workout system and you want to and the workout system is just an interesting way to try and get people into the app, right? So like I don't know what your goal is with this, right? Like I know the goal of my current app. My current game is make truck run into people and people die. Ragdoll physics. Right? That's all my game is. Everything else is fluff around it, right? For me, it was game first and fitness second. Okay, so if that's the case, then why the fitness aspect? Not that it's bad. Like again, I'm not saying that it's bad. I'm confused as to how the fitness side of it makes the game better. right? But like, I'm not saying rip it out. I'm saying I don't understand it. But I'm also probably not your core audience because this isn't a game that I would play. Have you played Walkscape? I have not. Right? Your game doesn't sound like a bad idea, right? And your trailer could use some work. But the game as a whole, it sounds like it's going to interest some people, right? So I'm not saying scrap your game. I'm not saying that you're going in the wrong direction. I'm asking questions as somebody who's just watched the trailer and would probably never play it. And it's not because it's a bad game. It's because it's a style of game that doesn't appeal to me, right? And that's okay because my game will not appeal to everybody as well. There's going to be a large section of the population that has zero interest in my game, right? And that's not a bad thing. The more focused that you can be on the target audience and the more you can get it out to that target audience, the better your game is going to do anyways. Right? So I'm guessing Walkscape is like a walking based game. Does this have to do with actual walking or is it just like do you actually have to like walk around the world? Because that's kind of interesting. That's kind of cool. If that's the case, I might install this next time I go to like Japan. I do so much walking in Japan. Like I imagine it is. I don't know anything about this game. Ultimate beginner guides to Walkscape. Let's take a look.
Hi everyone, I'm Eric. I run the Walkscape Tips YouTube channel.
I'm Shampoo. I'm the lead developer of Walkscape. Walkscape is a MMORPG that is inspired from classic games such as RuneScape. But the main difference between Walkscape and other MMOs is that in Walkscape, every type of progress that you do in the game requires you to walk into real life.
So here I am looking at
Okay, yeah. Yep, walk in real life lets you do in-game stuff like crafting, attacking monsters, etc. Yeah, okay, so that's cool. So it's a fitness app. That's kind of neat. It's cool, and like Pokemon Go kind of did the same idea, right? Where everything's about exploring and walking. So yeah, like if this is something that interests you, you don't have to rip the workout aspects out of your game, because arguably the rest of your game is not super compelling without the workout stuff, right? Like the workout stuff is interesting, right? You're going to have a much harder time finding an audience without the workout stuff than with the workout stuff. Because the workout stuff is an underserved audience, right? Just like Walkscape, the walking aspect of this for a game that can be interesting is an underserved audience. Because there's only like two that come to mind, and Niantic made both of them, and it's Pokemon Go and the Niantic branded version of Pokemon Go. Right? So like outside of that, there's really not that much like interesting in that space that I know of, right? Outside in Walkscape, which I just found out about. So like there's nothing there. I don't know if I would say take anything. I don't know. Yeah. I think you're moving in the right direction, and you need to be unattached to anything that is not core part of your game, and do not be afraid to rip it out if you feel like it's not adding to the experience. Also, sup Don. Good to see you again. Oh, Don, check it out. I finally got it working. Finally, after what, like 2 weeks, I got this working. The vehicle has an upward force. It is not the right amount of upward force, because that's just going to require tuning, but it has an upward force. Yeah. So we're on the very first aspects of the vehicle system now. Next is going to be actually fixing the wheels, because the wheels are broken right now. Actually, I shouldn't say they're broken, because that would imply that they ever worked. They kind of work. Like you can see that they're not centered properly, and that's because I actually do have a little bit of math actually pushing them down. So that's there. Yeah. But I was also like about to head out because I am tired. I'm tired and I need a break. Been at this for 7.5 hours every single day. 7 to 8 hours every single day. Monday through Friday. But yeah, I will be back tomorrow for a good 7 to 8 hours again. And the goal will be to fix the wheels. No, the goal will be to hopefully get the vehicle actually driving. And holy shit, I can almost make a tutorial on how to make a fucking vehicle. Dear God, by the end of this, I'm going to have a tutorial. I'm going to have a Unity tutorial by the end of this. If I don't gouge my eyes out first. All right. Let's see if there's anybody to raid. Ooh, let's go raid an artist friend of mine. We can raid one of two friends. Do you want a 3D artist or a 2D artist that looks like she's playing games? The 3D artist is sculpting anime girls. Actually, wait. I've got a programmer. He's not currently programming. He's also doing art. But he's under programming, so he'll probably go back to programming soon. He's doing game dev. Let's go raid him, and then I'll head out. 3D? Okay, yeah. We'll raid Rush. I haven't raided Rush in a long time. I warn you all, he is sculpting Big Booba anime characters that he will, not really anime, but Big Booba characters that are made for 3D printing. Wait, what? Did it slash raid? There we go. All right. As soon as this goes, we'll start the raid and I'll send you guys over there. But thank you to everybody who showed up. I will see you all tomorrow. And ta-ta for now. Yeah, no worries, man.